I saw him standing out there, so thank you for coming and helping us out in this meeting. We'll be happy to have any of your advice or experience as we go through this. I believe we're also webcasting this, is that correct? So whether you're here or listening, we appreciate the participation. We have an interesting year of surveys and results that we're going to work through. So the more people that we can have involved in this, the better result we will end with. So as we open this up, halibut stakeholders and users in both Canada and the United States are coming off what was a pretty good fishing year. Landings were up a little in 2017 compared to previous years. And so it was a little bit of a surprise when we heard at the interim meeting that the productivity of the stock is judged to be quite a bit down. So that's part of the unusual circumstances that I mentioned earlier. So it's going to make it a very interesting meeting, and we will look forward to the advice from our advisory bodies. At the outset, I want to express my personal thanks to the IPHC staff, the stock assessment people. I've gone through their stuff as carefully as I can. I admit that in the old days I was a stock assessment guy, but when my skills were bypassed by all the new young guys, I had to go up and write rules in Juno. So for 20 years now, I haven't really done much stock assessment, but I can't find any problems with the document. So I believe that is the status of the stock. So just want to express my support for those people that worked hard on that. We have bycatch concerns still. We should note that this last year was the lowest level of bycatch that has occurred since we started counting bycatch carefully in Alaska and other places. It's a major milestone. Commissions had a central role helping reduce halibut bycatch, halibut mortality in other fisheries, and the commission is intent on continuing those efforts to try to reduce the bycatch as much as is practicable. All in all, there's some pretty glowing outcomes from the Halibut Commission and the halibut fishery through the years. So the commission itself has a long history as a global leader in cooperative management, designed for the sustainability of the halibut resource and the halibut fishery. We are committed to continue that. We think that we made a number of positive changes in the management in both countries through the years, and we're pretty proud of the legacy here. So looking forward to the meeting this year, and I would like to see if Commissioner Ryall from Canada has any opening comments.
Thanks very much, Jim. And just to support the comments that you've already made, I do think that the International Pacific Halibut Commission has invested increased resources into the collection of data, but also into the analysis of data, and also have provided a forum that we are collectively involved in, the MSAB, that is looking to the future to how we manage the halibut resource as well. I think as Jim started out, it is nice to be in Portland. I haven't been down here myself for a while, and so it's kind of nice to see the city again and get outside and have a bit of a walk around. Well, having a chance to think about some of the issues that we will be faced with over the next 4 days. Clearly that there are some issues around what do we think the stock is doing and how do we need to respond to that. So we will have a presentation later this afternoon just to reacquaint ourselves on where we think the stock is, or where the Halibut Commission thinks the stock is and where it may be going, and some ideas about how we need to respond, and we'll have a number of days to come to a conclusion on that. I do think there as well, though, there is another substantive change this year, and this was, that the Commission will be negotiating on what's called TCEY versus FCEY. And that may not seem like a substantive change in some regards. In others, it's a fairly substantive change. And I think we should keep that in our mind too as we think about what we want to do this year. So looking forward to coming to a conclusion as we have in the past collectively and achieving a consensus. I think it could be a little bit challenging, but nonetheless, I do think we have the tools to come to an agreement and move forward. So thanks very much.
Thank you, Paul. David, do you have some comments on the agenda?
Thank you, Chair. Just a few quick words, I guess, in terms of what the Secretariat firstly has provided all of you as information for this meeting. The staff have worked tirelessly to ensure that we're providing you with the best possible scientific advice throughout the course of this meeting, and we do encourage you to access that information if you haven't already done so. I guess as a general sentiment, we are encouraging, as you would expect, that the decision-making process, as much as possible, uses that best scientific advice in making its decisions, noting that there are some very tough decisions to be made at this particular meeting. So we would encourage all to engage in the discussions and where needed to take a precautionary approach to the management of Pacific halibut throughout the convention area. In terms of the agenda, Chair, I guess it's just whether anything we would like to add or retract from the agenda.
Any commissioner with suggestions, changes, additions, subtractions from the agenda? Okay. I see none. Can we adopt that? We adopt, oh, please.
Do you need a motion?
Please make a motion.
Motion to adopt the agenda.
Is there a second?
I'd second that.
Any opposed? No opposed. We have adopted the agenda.
Thanks, Chair. So from the agenda, we have a number of meeting arrangements. First of all, you'll notice that there's quite a few changes we've made to the way we're providing information to you, both through the IPHC website and then also through other means for the various advisory bodies. At this point, I'll pass to Steve Keith, who will run through some of the other logistical arrangements for the meeting.
Thank you, Dr. Wilson. Just as the director mentioned, the website is full of information. It's also a new website. We'll be talking about that a little bit later this afternoon, and we appreciate your comments and feedback on the new website design. For those of you looking for the RARA, the Report of Research and Assessment Activities, that is a link at the bottom of the meeting documents on the meeting page on the website, so you'll find it there. As always, the Secretariat staff are here to help you through the course of the meeting, and we have tables in the back of the room. And we have also, so we can organize the public comment, we have a sign up, which is on a computer station at the back of the room there for you to sign up. And you can indicate your name and the topic that you want to talk about. And then rather than having to line up and figure out who should go first, we'll call up everybody who's signed up when it's time for a public comment. And as always, any member of the staff is here to assist you. You'll see us, and you'll note that everybody has different colors on their badges, but the staffs and the commissioners are yellow. Thank you.
Thank you, Mr. Keith. So I believe the first public comment is going to be at 5 o'clock this afternoon after we complete much of the introductory stuff on stock assessment. So sometime prior to 5, if you would like to make a public comment, as Keith said, Steve Keith said, please sign up back there. So I see that on the screen we flashed the list of documents and those things, so I think you understand where all of that is on the website. I think that can bring us to our item number 3, which is an update on actions from the last annual meeting. Dr. Wilson.
Thank you, Chair. So as we bring up paper 03, okay, so as the title says, the purpose of this document is just to provide, I guess, a summary of the actions that the Secretariat and others have been undertaking in the intersessional period between the 93rd session of the annual meeting and also a follow-on from the 93rd interim meeting, which was held last November. Appendix 1 of this paper details all of those recommendations and requests from those bodies, and we'll just wait till that comes up. I don't intend to go through each of these individually, as it's quite lengthy, but just a reminder, we've seen this document before, that it does list the various action items arising from both the commission meeting, the annual meeting rather, and also the interim meeting. In the left-hand column, the description of the recommendation or request made from the commission, and then the update, and you'll notice it's color-coded in terms of whether it's complete, ongoing, or in process. Chair, I could either step through those which are in progress, or we could just leave it for information, noting that all of these are dealt with throughout the course of the meeting in various meeting documents and presentations. So I'll leave it to you, Chair, to decide how you'd like to proceed.
Any commissioners have thoughts? I see none. I'd suggest we go to those that are not completed, if there are a couple of those, and then attendees can look at the list of completed ones, and if there's something you want to discuss, it could come up during public comment, and we can pick it up later. But for now, let's jump to those that are not done.
Thank you, Chair. So if we go to recommendation 10 from the annual meeting. So as you can see, it's color-coded in blue. This is a recommendation that originally came from the Research Advisory Board and was endorsed by the Commission, and it's to develop best practice handling guidelines for starting with the directed fishery, the longline fishery, and then also eventually looking at the other fisheries or fleets and other gear types catching halibut. At this point, this is being folded into the research program, and we expect that this study will be completed in late 2019. If we move on to the first request from the annual meeting, this is to do with the survey expansion through 2019. I think I skipped over one there, but we'll come back in a moment. This is an in-progress activity where we're working closely with various agencies, in particular DFO, noting that the expansion is due to take place in Area 2B in 2019, to look at ways of minimizing the impacts of the Fishery Independent Setline Survey on both sensitive areas or species of concern. And in the next presentation, the report of the Secretariat, Steve Keith will also give a little bit more detail in terms of that engagement, particularly with DFO. If we just pop back to the previous one, I skipped one there by accident, in terms of recommendation 13, the IPHC performance review. This is dealt with under paper 16, where we provide an update on progress in implementing the second performance review of the IPHC. And we'll be discussing that, I believe, on Thursday morning in detail. So I won't go into any more detail at this point. If we skip on to request number 2, to do with the management strategy evaluation process. Again, this is going to be dealt with in a paper for the meeting, paper 12, and that'll be presented by Dr. Hicks, and then also the co-chairs of the MSAB will also touch on that first thing tomorrow morning. We move on to request number 5. This is to do with a request for the Commission to engage the North Pacific Fisheries Management Council, both in terms of discussing areas of mutual concern and interest, and also holding the joint session. This was actually, no, I think I've skipped one ahead there. This is talking about the trawl side of things for the surveys. Okay, so this is going to be, it wasn't done in time for the annual meeting, but Agency Report 02 will address that, and I'm hoping that we'll have the relevant agency staff to present AR02 at that time. Request number 6 for the Scientific Review Board. This was again for the Scientific Review Board to look into alternatives for eBio, and we have Dr. Sean Cox, who's going to be coming to present the SRB report. We're going to move him around the schedule he's only flying in, and he'll be giving that at about 10 o'clock tomorrow morning. So if you're interested in that particular recommendation, Dr. Cox will be available at 10 o'clock tomorrow morning. In terms of the interim meeting recommendations, IM093 recommendation 01, the Commission last November requested that the Secretariat provide a detailed description of how the regulatory area 2A commercial fishery was managed, and this is detailed in paper Inf 02 on the website, and that again will be dealt with a little bit later in the meeting.
I think we're okay, we're just...
Okay. Recommendation 02 from the interim meeting was about the fishery goals and objectives, again being dealt with through the management strategy evaluation process, and the co-chairs and Dr. Hicks have also put together a presentation that they will provide to you tomorrow morning in terms of the consolidation of those goals and objectives and discussion with various stakeholders. So that'll be held first thing tomorrow between 9 and 10 at some point. The requests that are arising from the interim meeting, the first was to do with looking at bycatch levels in the various fisheries, and that is summarized in information paper 03 and will be discussed soon after, later this afternoon, is the presentation of paper 05. In terms of request 02 to do with the space-time modeling of survey data, the Commission requested that the Secretariat provide alternative ways of computing bottom area. This I don't believe has been updated yet. However, Dr. Webster will provide an indication of where things are at in his presentation later this afternoon. Request 04, which was to do with looking at projected bycatch reductions and in the non-directed fisheries, particularly in the Bering Sea, and we believe this is going to be presented as part of Agency Report 13, again, if the agency staff are going to be present. If not, we'll find an alternative way to pass that information onto the Commission. Request 05 is again to do with the Management Strategy Advisory Board, and I believe we provided this information, which will be presented by Dr. Hicks tomorrow between 9 and 10. Request 06 similarly links into the goals and objectives, which we just spoke about, and again that will be presented between 9 and 10 tomorrow morning. And finally, the staff are still developing, or going to be developing rather, a template for the agency reports as requested by the Commission, and that will happen in the intersessional period. And so with that, Chair, I'll pass if there's any questions.
Are there any questions on that? Ms. Bengen.
Thank you, Mr. Chairman. I do have a question for you, Dave, on, and maybe as much to inform the public as to answer my question, but on page 5, the number 2 there relative to the in-progress MSC request to the Secretariat initiate process to develop alternative biologically based stock distribution strategies for consideration by the Commission and its subsidiary bodies. So I guess my question is, are we anticipating some public comment at this meeting on that? Are we anticipating that the Conference Board and the PAB may have some discussion on those topics?
Thanks. Through the Chair. Yes, we'll certainly be presenting information in that regard throughout the course of the meeting, and where possible, both the Conference Board and the Processor Advisory Board are encouraged to hold a discussion on those items. We have communicated a circular on those particular items, trying to encourage engagement and input from stakeholders. And if we were able to receive direct input from the two boards to the Commission, I think that would be highly beneficial. Thank you.
Thank you. Any other questions, comments? So I realize that when we talked about the agenda, I don't think it's I doubt anyone here doesn't know that the U.S. government failed to fund some of its, most of its agencies, and so we don't have National Marine Fisheries Service staff here. So they were designed to give some reports. We do believe there's some reason to expect that these furloughed employees will be coming back to work soon. It's not clear how quickly we can make them travel, but we will try to accommodate them if they can't be here in person, by telephone, if the furlough truly ends. And so if we scramble a little bit trying to figure out how to get all the agendas items addressed, that might be some of the background, but we'll try to make it really look cool. So on that, can we move to number 4, which is you, Dr. Wilson, the report of the Secretariat.
Thank you, Chair. So as we wait for the presentation to be brought up, Thank you, Chair. So the intention of this particular presentation is just to give you a quick overview of some of the activities of the Secretariat, noting, of course, that most of the meeting is devoted to providing updates on the activities of the Secretariat over the past year. So if we move to the second slide or next slide. Staffing changes. We've had 2 full-time staff leave and 2 full-time staff depart. It's a much reduced attrition rate than we've seen in the recent past, providing quite a bit of stability to the Secretariat. And as a result, we've been able to implement quite an amount of additional work to make improvements to the way we operate and provide you with the information that you need to make decisions based on the best possible scientific information. If we move to the next slide. We have held almost the full range of commission and subsidiary body meetings throughout 2017. The only change would be to the Research Advisory Board, where we've moved it from November of each year to February. And so we'll be holding that Research Advisory Board meeting at the end of next month. And the reason for that change was to better integrate the activities and the advisory nature of the Research Advisory Board into the newly established 5-year research program developed by Dr. Planas. And so we will, as I mentioned, be holding that meeting in Seattle on the 28th of February next month. The other changes were primarily to do with the Management Strategy Advisory Board. The Commission has recommended over the last year or so a number of measures to increase the activity of the MSAB, and more specifically the work of Dr. Hicks for the Management Strategy Evaluation. And as a result of the increased workload and material that Dr. Hicks has been presenting and preparing, rather, it was required to expand the duration of the MSAB meeting to be able to thoroughly consider, discuss, and make recommendations to the Commission. And this will be also done into the future, both in 2018 and 2019. Next slide. Just a quick recap in terms of the past year, 2017, the Commission adopted 4 regulatory proposals at the last annual meeting. The most substantial being the fishery regulation modification to Section 13 on size limits, or more specifically, the requirement to land commercially caught Pacific halibut with the head on. There was an exemption as part of that regulatory amendment or change, and that being the vessels that freeze Pacific halibut were permitted to land halibut with head off. A quick update: in 2017, the exemption resulted in only 31.9 tons, or around 70,000 pounds, being landed with the head off, which is quite a small amount and not considered at this point any significant level. And we'll be reporting out on this a little bit more as part of IPHC Proposal A5, which is a discussion paper on the implementation of that particular amendment. I should also mention that all those vessels, the 28 vessels, were Canadian vessels. There was no US vessels landing halibut with their head off in 2017. Next slide. The other three are relatively straightforward. The first, in terms of a modification to Section 18 of the regulations on fishing in multiple regulatory areas, and I believe the agency staff are going to provide a short update on whether there was any problems with the implementation of that particular amendment later, probably tomorrow or the next day. The other two are the standard modifications to catch limits and fishing periods, and we'll be receiving updates on those very shortly as part of the fishery statistics presentation by Ms. Goen and Ms. Erickson. Next slide, and we'll move into some updates on interactions with the agencies, and I'll pass to Steve Keith to provide those, Chair. Thank you.
Thank you, Dr. Wilson. And this is just a few slides on the Secretariat staff's interaction with the agencies of the two contracting parties during the course of the year. You'll hear more from the agencies themselves when it comes time for their reports. The reports from regulatory areas 2A and 2B are tomorrow afternoon, and the reports from the Alaska regulatory areas are Wednesday morning. So during the course of the year, we've had a very productive engagement with Fisheries and Oceans Canada regarding the expansion of our setline survey in 2018. And I should say at the top of each slide here, you'll see the names of the reports submitted by the various agencies. So there's 3 different reports from Fisheries and Oceans Canada reporting on their activity during the course of the year relative to Pacific halibut. So as I say, we've been engaged with Fisheries and Oceans Canada all year and continue to be so as we plan for the expansion of the survey in 2018 in British Columbia. And in particular, there are 2 things that have highlighted our conversation. Those are areas of concern, the marine protected areas and the rockfish conservation areas, as well as species of concern, in particular yellow eye and boccaccio. And that conversation is ongoing, and you'll hear more about that as we talk about the survey in one of the later presentations this afternoon. And the other conversation that we've been having with Fisheries and Oceans Canada during the course of the year is about the process of estimating distribution, and as has already been alluded to, there'll be some more discussion and presentation about that in conjunction with the management strategy evaluation presentation tomorrow morning. That's agenda item 7. Next slide, please. With the U.S. National Marine Fisheries Service, NOAA Fisheries, we've been engaged throughout the year on regulatory proposals, both the ones that went into place this year in 2017 and the ones that NOAA Fisheries has proposed for the coming year, which you'll find among the regulatory proposals as B1 through B3. And as Dr. Balsiger mentioned, at some point we hope to hear from NOAA Fisheries on their own regulatory proposals, and there may be some adjustment to the schedule as we accommodate their return from a government shutdown. At the top, there are the 2 papers. The first one is the NOAA Fisheries report from the West Coast region, and the second one, AR13, is the annual report from the NOAA Fisheries Alaska region. Next slide, please. Our engagement with the U.S. Fisheries Management Councils in the North Pacific, it's been a lot of different things going on during the course of the year. At the top, you'll see their report to the IPHC. We've been engaged in halibut management framework actions during the course of the year, especially with abundance-based management. There's a work group composed of scientists from various agencies, including the Halibut Commission, to work on abundant-based management of Pacific bycatch, Pacific halibut bycatch. And the other work group has been working on discard mortality rates, and you'll hear more about that at different points during the course of the day. The Commission met with the North Pacific Fishery Management Council in June on the side of the Council's regular June meeting in Juneau this year. And the last point there has to do with the management measures for the Alaska regulatory areas that you'll hear more about that the North Pacific Council is proposing to the Commission as part of the regular cycle of management updates. Next page. And our engagement with the Pacific Fishery Management Council has largely been about the catch sharing plan. Every year, the Pacific Council considers changes to the catch sharing plan for regulatory area 2A And this year, they are presenting a couple of changes that they have made that have to do with the recreational fishery in Washington, and no other significant changes to the catch sharing plan for 2018. The other conversation that we've had in an ongoing way with the Pacific Council has to do with the commercial derby fishery, particularly the non-treaty directed commercial Pacific halibut fishery in regulatory area 2A, which is one of the last derbies in the United States, if not the last derby in the United States. And we've talked about ways to move away from the derby style of fishery management. And it's been an agenda item at 3 of the council meetings during the last year, and the council is still considering it, and we're still engaged in conversation there, and we expect it to be on the agenda at the June Pacific Council meeting. No changes are being made or proposed for the commercial derby fishery for 2018, but we hope that in coming years we will be able to move away from the 10-hour derbies that we have grown to know and love. And that's it for the council.
Thanks, Steve. The final element for me is just to highlight the annual reporting process that we have improved upon and expedited. And we will be working with all of the staff to produce the full final 2017 report soon after this meeting. So we do hope to publish the report for the year of 2017 by the end of February. And that will be obviously published on the website. Which brings me to the next point, which if we just go to the next slide, and then the next slide after that, is the IPHC website. I'm sure you're all very well aware of the IPHC website's launch, which was back in last month. It seems so much longer at this point. But the staff has worked quite tirelessly to improve upon the way we communicate information and make that information available in general to all stakeholders. And as a result of that, the team has worked for over a year to produce what is currently the new IPHC website. Noting, of course, that it's certainly not perfect, and we are going to continue to improve upon it. But as I indicated, the intention is to provide all of you with as much information as we possibly can in the most simple, easily accessible format possible. So as a result of that, I'd like to thank the team as a whole for the work that they've put into developing this new website. And I'd like to pass to the lead on that project, Mr. Keith Jernigan, to provide you with a little bit of an indication of how to find some of the information, particularly for this meeting, and some of the core changes that have been made to the way that information is presented. So through the chair, if I may, I'll pass to Keith.
Thank you. Thank you, Dr. Wilson. So as Dr. Wilson mentioned, the website has been a project of ours for the last year. We have worked on it to ensure the information is available to you folks as quickly as possible and easy to navigate. So hopefully you've been there, but what I'm going to do is give an overview on how to get to our meeting documents and our publications. As I'm bringing up the website here, and attempting to get my mouse to work. What a mouse. I'll tell you what, let me sit over here and drive. Thank you, Jay. So we have our top level menu items, the commission, which will give you information about the commission, science and research. On each of our menu items, on the left side, we have quick links and we have menus for each of the categories. Our quick links here will be on most of all the pages that you navigate to on our website. And again, I want to go over these quickly because I want to spend most of my time on the meetings and the documents. Science and research here with the different categories of information available to you. Fisheries, an overview of the fisheries. We have our data, including our survey data that you all are familiar to, and you'll get a lot more of that after my presentation. Meetings, why we're here today. Okay, on our meetings page, on the left side, you'll see bookmarks or shortcuts, if you will, to our meetings, our annual meetings, intermeetings, and our subsidiary body meetings. You can click on either one of those and it will take you to the meeting calendar with those meetings listed, or you can go directly to the meeting calendar from the left here. You'll see also on the front page, lost my mouse here. Thank you. On the front page here, we'll have our featured meetings. So you will see here we have our interim meeting and the annual meeting to keep within that meeting cycle. I'm going to demonstrate live for you our annual meetings. By default, it comes up for the current meeting because of my filter for the current year. An easy way to navigate to different meetings is the calendar here to the left. You can forward or go backward. What I want to do is change the date here from 2017. I'll get in here and just type it real quick. That wasn't quick enough. All right, my calendar's a little bit too big for this screen. Although we are at 100%, I'm just going to reduce it just a little bit so I can get access to that calendar. There we go. All right, for the demonstration purposes, I did minimize the screen to show you that I can change the filter and now get a list of all meetings. In this case, I changed my bookmark. I reset that filter. So now if I want to see only the annual meetings or any one of the subsidiary meetings by category, I can choose it here on the filter for categories. And because we were looking at annual meetings previously, I'll go ahead and choose that one. And with the date set at 2012, I'll hit search or submit rather, and you'll see a list of the annual meetings. Demonstrate a couple more here, the Management Strategy Advisory Board. Now, you can click on the meetings here and go to the meeting page. Here, you can see the 10th session of the IPHC Management Strategy Advisory Board with the information about the meeting at the top of the page, the location on the left, and then the meeting documents listed down below in a table with a document name, the title, a link to the PDF, and the date that it was published. If there's an associated PowerPoint presentation, it will be available there as well. I want to show you the annual meeting that we're here for, the meeting page here. On this meeting page, you see that we have the registration link for Eventbrite and the registration link for the webinar. Navigating the document, navigating the IPHC meeting is right here. Hopefully you folks have seen this. Now, I'm going to click on this to show you the file. This is available on our website, help you navigate this week's sessions. But you can also simply just come to our website by typing iphc.int, and this works for mobile devices as well, whether it's a smartphone or a tablet. You have the schedule here listed by day. Now, as we progress through each session and each day, those sessions come off the calendar. That's why you only see the 2:10 session right now. Moving over to Tuesday, Wednesday, and we took images of the hotel's layout of the floor plan and created links to them right here. And these are available to you. You can click on them and get a layout of the area for that particular session. Okay, as with the Management Strategy Advisory Board and all IPHC meetings, the meeting documents are listed here. One document I want to bring your attention to in particular is document number 00, which really isn't a document in itself. It's a collection of meeting documents. So every meeting document you see here on this page is available for download individually, or you can download one single PDF, the 00. I say 00 because it is appended with 00. We have standardized all of our naming conventions, and 00 is the collection of meeting documents. So I'm going to go ahead and click on it to bring it up. It's a rather large file, again, because it does include all the meeting documents. We just uploaded a new version of this file. It has grown from 30 megs to about 40 megs. So I will allow that to download and continue showing you the website. We'll get back to that in just one moment. Okay, all the documents are listed here by category. Our Assistant Director, Mr. Keith, mentioned the RARA. The RARA is available, the RARA, at the bottom of the meeting document. And of course, it's also available along with all of our other publications in the documents folder on our website. And I'll get to that in just a moment. We're about halfway there. We'll come back to it. All right, documents. Now you have access to all of the meeting documents from the meeting page. You also have access to the meeting documents from the document library. Individually, you can simply choose the same categories that we did on the calendar for different you can select category like you did in the meeting calendar, but category of documents and publications to pull them up. Again, like the meeting calendar, you have your bookmarks or shortcuts, if you will, on the left side. And then again, under category. What we've also done is either duplicated the category or included an additional keyword search or a tag for you to search our document library. And here are the tags available for you to search, including the RARA. I'll go ahead and get that one. It seems like it's pretty popular. So they're all listed here by year. And I'm going to click on the most recent one, 2017, to show you how exactly this was published. We do have the outline of the RARA. We have the document here in its entirety as published, linked here. Now, with each paper that is referenced inside the RARA, we went ahead and created a link for you right here at the bottom to those individual papers that are referenced within the RARA. If that doesn't make sense, if you open this link and look at the chapters for that particular section, you'll see that it is referenced a particular paper that we have placed on our website for that RARA entry, or RARA, as other folks know it as. Okay, going back, I will say this, folks, when we're inside meetings or documents on the website, it's critical that we're using the functionality within the website and not the web browser. So if we start using the web browser functions for forward or back, and we're inside the filter and using the functionality inside the filter, it's not going to work. You'll quickly figure that out. So again, just using the capabilities or the functionality rather inside the meetings and the document pages. Okay, I do want to get back to the collection of published meeting documents to demonstrate what we have here. The papers are categorized by the ones that you saw on the website. You can go directly to them. You can go to paper number 2. Paper number 2 has each paper hyperlinked. So if you wanted to go to paper 11, which I'm not going to click on right now, it would bring it up. You go, well, I'll go ahead and click on it. You take it right down to that paper within this document. Okay, moving on to documents. Our scientific reports and technical reports, I want to call this out because we've included an index in addition to each document within in addition to each scientific report that has been published, we've also included an index. So within our document library, our scientific report index has a listing and a link to each report. Now, you can also pull up the individual reports themselves, or you can search for them by keyword. I want to show you meeting documents. I want to show you meeting documents because we've standardized the acronyms, if you will, for each meeting session. For example, this meeting here this week is AM094. If I wanted to find all the documents in the document library for this meeting, I would simply type AM094 in the keyword search. If I was at the conference board or the PAB, I'd do the same thing for the particular session that I wanted to see the meeting documents for. So we'll demonstrate with AM094. And you'll see that each entry is preceded with the name of the file or paper. And you can click on either one of them. There's a number of pages here of them, but you can click on them and then you will get the individual paper that was published. If you get lost on the site, you're not sure where you want to go, of course you can always search here or down below on the left bottom on our footer. There's something called a site map. Take a look at the site map. It has every page on our website listed here. You can click on the link here and get to a particular page. You can come here and search through your browser. In addition to our staff, meeting calendar, and our individual meeting pages. Now, I want to go back to meetings real quick. I want to go back to the interim meeting, our IM093. The reason why I wanted to come here is to show you what we post or publish after the meeting. So you did see AM094, and we started off with Secretariat meeting documents or meeting documents. Well, with the IM093, we included the report of the interim meeting. We included the news release, and we included a link to the webinar recordings or the webcast that we published on YouTube, our YouTube channel. So this is after the meeting. The papers are still here, and you'll have the report, news release, and the webinar in one place. Dr. Wilson, with that, I believe that covers it.
Through the chair. Thank you very much, Keith. I think there's also a couple of computers that are set up outside where if you are having difficulties finding something on the new website, please do ask any of the staff to walk you through where that information is located. Thank you very much. The only other element that we wanted to touch base on, noting that there is going to be a lot of discussions about the Fisheries Independent Survey results, is the new interactive maps and data querying tool on the website. And to undertake that, if I may, Chair, through you, bring Mr. Eric Soderlund to the podium to give you a brief overview of how to access that survey information. So thank you, Eric.
Thank you, Dr. Wilson. Give me just a minute here so I can figure out how to drive this mouse. All right, there we go. So I'm going to be talking about the interactive maps and data, my favorite new part of the new website here, and I want to give you tips on how to get started and show you an example of how it works. So we wanted to give you our Fisheries Independent Setline Survey data in a way that makes it easier for you to see trends and to dive deeper into the survey data and ultimately get a deeper understanding of what's going on out there. So any of you who've looked at our data in the past have seen tables like this. These will continue to be available on the website, and it shows the catch at every station, when it was fished, and you know, sublegals, legals, and that sort of thing. But unless you're good with Excel or ArcGIS, you can't get a whole lot out of these data tables. So we're providing you the data in the same way, where we're using the same data set that you saw up there, but each of these points represents a station that we fished in the year you have selected. So I want to walk you through these and teach you how to use them so you can start exploring the data. In this talk, I'm going to show you what's available, where to find it. I will give you some usage tips and some orientation tips, and then we'll also go on a data exploration example to show you how I've used these to answer some questions that I've had. So what is available? We have the raw Fisheries Independent Setline Survey catch per unit effort data expressed in numbers per unit effort and weight per unit effort. And when I say raw Fisheries Independent Setline Survey data, I mean the data that, as it is when we see it on the boats we hire to do the work. It's before the quantitative team has done any adjustments for bait competitions or the timing of the commercial fishery. So this is what we're seeing out there on the boats that we hire. And we're expressing these numbers or aggregating them in U32s, so sublegals, O32s, legal size fish, as well as all sizes. So you can take a look at these data grouped in those groupings. So where to find it? Keith Jarian just showed you that the top of every page on our website has a navigation bar, and there you click data. And that will take you to a screen with this in the center, the IPHC Secretariat Data Holdings. This is where you'll find both the traditional survey data, like you've seen before, available in Excel files or PDF files, as well as a new custom download tool that will let you select certain areas or a range of year to only get the data from that, so you don't have to weed through all of it, and so you can work with more years at once, as well as the interactive map. Before I get into the interactive map, I do want to show you quickly how the custom data download tool works, and I have a little video set up for that. What you do is you select a range of years, you can select specific data fields, and you can also have a map-based selection. So here's a video I recorded of how that works. You click on the screen. You notice it takes a bit of time to refresh the database. Depending on your internet connection, you may have to wait longer or shorter, and depending on the time of day, how many other people are accessing it too. So have some patience. Here I'm adjusting the year to from just 2017 to 2014 to 2017. I should also mention, after I'm here, so now we'll go through, look at the data fields. I want to keep all the data fields, but I'll show you an example here. Let's just look at 2C data. So that's what I did there is I selected area 2C, and you'll see it zooms in on the map there. The dots are kind of hard to see on this screen, but I just want to select a selection of those stations. So I can use the map tool to select those, and that will filter the data download there on the, just to the right of the map. And you can see if you scroll through there, it's only stations within that area. I know where the station numbers are, so I can guarantee you that's 2C. But down at the bottom, to get that data, you click down there and you click download. You click download crosstab, it will give you the columns in the order that you've seen there. And that's what it looks like in Excel when you look at it. So it's just a quick way to filter the data before you download it and to allow you to get multiple years of data at one time. Okay, on to the interactive maps and data. I showed you this one before. We have 3 different interactives for you. We have the single map, which is on the left. We have the middle one, which are multiple maps. That's a map for every year that we have in the time series. And then next to that is a interactive of line plots, where, and I'll go through each one of these in our data exploration example. You might have noticed on the top of each one of those there was 5 buttons, yellow buttons, and that's how you navigate from each interactive to the other. But the first 2 on the left are some information to help get you started. The overview guide has definitions and description of the components that you're looking at there, among other things. And the map usage tips, which I highly recommend you give a read before starting to play with the maps, because it'll be very frustrating if you haven't gotten the just the primer on how to move around and how to select those stations. So take a look at those. But after you've worked with it a while, you probably won't look at those 2 tabs ever again. Okay, so this is where you'll probably start most of your investigations, on the single map page. And it's built of 5 components. And along the top of all of the interactives I have for you is where you'll find your filters and controls. And that's what you will do to select the data you're looking at, and then also how it appears on the map there. Below that, you have your catch per unit effort map, and that will display whatever catch per unit effort, numbers or weight that you've selected. To the right of that is a panel that lets you look at the depth and distribution of effort and catch based on what you've selected. And below those are 2 data panels. The one on the left gives you the catch at the stations over at the top stations in the selection averaged over the year, and the bar chart ranks them from shows you the top stations in your selection there. And these are all described too in the information or in the instructional panels that I mentioned earlier. I also should say that I'm going through a lot of information fast here, and after my talk for the rest of the day, I'll be available in the foyer outside with a laptop to walk you through it again, answer any questions, take suggestions, and that kind of thing. Okay, so I want to show you how these work to get started. So the first thing you want to do is decide what catch data you want to look at. So numbers per unit effort, weight per unit effort, sublegal size, legal size, or a combination of both. Then you have an option to zoom in on a particular regulatory area if you don't want to look at the whole stock itself, or all of them at once. And then third, you can select the year for the data that you want to look at. And you'll notice it's a slider, and if you click that arrow, you can go from year to year, back into time, and then back forward into time. Also, along the top are the controls, and these are used to adjust how the marks are displayed on the screen. It doesn't affect underlying data, but it will help you see things easier. You'll be able to increase or decrease the size of the marks. You'll also be able to adjust the maximum value of the legend to give more differentiation between the colors when you're in different regions. And I'll demonstrate these too as we do our data exploration. So like I said, this map here, every one of those points represents a survey station that we fished in the year selected. And the color is the catch, or the catch per unit effort, depending on what you selected there. Purple's being low, red's being high. If there's an X there, that means there was no halibut captured on our survey that year in that particular grouping, whether it's oversized or legal size or sublegal sized or all together. When you hover over any one of these points with your mouse, you will see what's a tooltip that gives you more information about that particular station in the year that it was fished. You can see it changes as you move here. And a close-up of what you're looking at there, when you hover over each station, you see the station number and the regulatory area that it was in. Then you'll see the weight per unit effort, both for sublegals and legals. You'll see the time series average at that station, as well as those numbers for the station for the year that you have selected. The same thing goes for the numbers per unit effort. Also at the bottom is the timing, so you can see the date that we surveyed that station and the location of that station, as well as the average depth. All right, I mentioned the depth bins right next to it. Takes a little bit of thinking to wrap your mind around what you're seeing here. But what it is, the length of those bars shows you the average CPUE within the depth band. You can see they're either 50 meter or 50 fathom depth bands. You can select there between meters and fathoms. So obviously when you select meters, you'll get a finer resolution there, about half a fathom. you can use these depth bars or depth bin bars to see where survey effort is focused in which depth bins. And I'll show you that if you click on one of those depth bars, it will highlight the stations within that depth bin. So I clicked 150 to 200 there, and all the stations that you can still see fall within that depth bin. So you can, let me just go back there, oops, sorry. And you can see that, you know, most of the catch, or most of our survey effort is within the 50 to 100 meter or 100 fathom depth band. All right. So I want to explain the rest of the components by way of a data exploration journey. And what I mean by that is, like, you have a question about our survey and you go in here to answer that question, and that makes you scratch your head and ask another question, which leads to another question, and eventually you'll have a deeper understanding of the fishery and what we're looking at. So in 2017, we heard great reports from fishers in 2C that they were having excellent catches this year. You know, we were happy about that, and I wanted to see if our fisheries independent setline survey also was seeing good catches in area 2C in 2017. So I will show you here. I recorded a video so I don't have to deal with slow internet if that's an issue. What we're going to do is I'm going to select the catch that I want to look at, and I want to look at weight per unit effort of legal size fish, because that's what's being landed at the docks, and that's what everyone's excited about. Now I'm going to go select my regulatory area, clear those, and select 2C. Now the map will refocus on area 2C, and it's going to ignore all the stations outside of 2C. It's a little hard to see, these dots are so small, so we'll use this adjust mark size to increase the size of these dots, and then you can actually see a bit what's going on there. See a lot of red dots. You can see 300 there is the maximum value on the scale. And I'm looking at the values, and I see what 400, 300, some good catches there. Those were good catches on survey as well in area 2C. And to look a little bit deeper here, you can see in the average comparing 2017 to 2016, you can see most of those are higher numbers. There's a better way to make these comparisons, but yep, first look, looks like legal size catch on survey was also high in 2017. That makes me ask another question. Well, where was that top station in 2C, and how are the catches nearby? So to find that top station, I can use the bar chart on the bottom, and if I click that top bar, it's going to highlight that top station in a second. There it is, the red one in the bottom, and that is station 3025. Okay, if I want to look near there to see how that catch was, I can use a map selection tool and select the stations right near there. And it's going to filter all the other stations out of the data that you're going to see both in the depth bin side and the table below and the bar charts. So you can see, well, not all of the catch was high right near that station. Okay. I think that's going to raise another question. I'm wondering how the sublegal catch was in 2C and maybe around that station. So in order to see what the sublegals look like, I just need to go up and select the under 32-inch numbers per unit effort. Their weights are all going to be fairly similar by fish. And look at there, I can see that the previously 3025 did not catch the most sublegals, which is not surprising. All right, now I look here and they're all purple, so I need to change that maximum value of the number scale so I have a little more color differentiation. It's not changing any of the values, it's just changing their coloring. Move it back there till I can see some more red. That looks pretty good. What am I at? 8? 8 per unit, 8 per skate is what we're there. Okay, that's a utility of changing that color scale there. It helps you just bring out the colors that you're looking at. All right, now I'd like to see how things change over time in 2C. So you remember that we selected the year. We were looking at 2017. Let's look at the legal size catch first. So we're comparing it to what you guys are seeing on the docks. All right, so they're there. Now I'm going to just click back to 2016 and see how those dots change. I see fewer red there. That's a bit more red, it looks like to me. We're in 2014. I see fewer red spots there. 2013. I can see changes, but I can't really see any real trends or patterns. So that's why I decided to make a multiple maps panel for you. So you have one map for every year, and you can get an overview. And so the way this works is at the very top left, you have 1998, and the bottom right, you have 2017, and it's just consecutive through there. So to get to that panel, you click that multiple maps, yellow square. And we'll open there. And similar to the first one, let's select 2C. You can see in this case, you don't have to do these in order always. And then let's make sure we're looking at the catch data we want to. Change it from all to legal size fish. Again, here those dots are small. I think I need to increase the size. I see some color in there. There we go. Okay. Oh, I see some purple ears there in the middle, and then back up to red. That looks like a pretty bright red in 2017 in the bottom right-hand corner there. I'm going to change it to the sublegal fish. These are the undersized, are the ones that are not seen at the dock. And I'm going to adjust that maximum color value again to what worked in that previous one. And I feel like I see more purple in 2017. And if you look at the bottom, there's some line plots too of the numbers per unit effort. And that kind of confirms what I'm seeing there. You'll notice that you can't get that whole image easily on a screen just the way our screens are set up unless you have yours set up vertically. But there is a way to download an image there. And so if you go down to the bottom right, same place as where you downloaded that data, you can click image and it will output a file like this, either as a PDF or JPEG that then you can look at it all at once or print out or do with it what you like. Okay. So those previous interactive visualizations are great but you can't compare really O32 and U32 at the same time or all at the same time. And that's why I made the data plots panel for you. This is where you can look at numbers per unit effort, weight per unit effort, and average weight, also broken up by U32, O32, and all together. So here's how you access that. You again go to the top and click the data plots panel. And that will take you to this page. And here it's showing every regulatory area, but let's select down to area 2C again. We'll clear them. Hit apply. Good. Now this is just 2C. And you see that the blue line is all sizes combined. The orange line is the legal size, and the green is the sublegal size currently, the U32s. There in NPUE, it looks like I see a 2-year drop in sublegals, although there is a good gain in legal size fish as well. There are various pop-ups as you play with this and go through it and look at things, explore them. If you have ideas for additions or how to make it helpful, you can contact us via the website. There's an email there. You can click it. It will be routed to me. You can send me an email directly. And like I said, I'm going to be out in the foyer there with the laptop and this on it. I'd be happy to run through any of the demonstrations I did or give you more examples or just talk about things. So, thank you.
Thank you, Eric. And I would like to think that everybody in the room has seen the utility of this tool that Eric has developed in conjunction with a number of others, but primarily through Eric's work. This does move us further towards maximum transparency in the information that we're collecting as an IPHC Secretariat on your behalf. And we do hope that you start to use that particular tool, scrutinize the data. It will result in more questions of us, but hopefully you become more familiar with the information that we're collecting using the Commission's funds, which I think is highly appropriate. So please do take the time. Eric is around for the next day or so to speak with him if you would like to understand the tool a little bit more. And I'm sure you'll be able to use it in your thought processes surrounding this year's survey results. We do intend, unless there's any objection from the Commission, to make the Fishery Independent Setline Survey data available each year as soon as possible after it's been processed and entered into the database. So unless there's any objection to that, Chair, I would pass back to you for the next agenda item. Thank you.
Thank you very much, and I think that is a demonstration of how we're trying to make everything that is collected, everything we know, available to all of the people that are interested. So any comments from commissioners? I see none, so let's move to the fishery statistics, please.
Thanks, Chair. So I'll call Ms. Gone and Ms. Erickson to the podium. Thank you.
Thank you, Chair. Good afternoon, members of the Commission. My name is Ms. Gone. I'm the Fishery Statistics Officer for the Fisheries Department. I'd like to start Good afternoon. I'm Jamie Goen, the Fisheries Statistics and Services Branch Manager, and with me is Laura Erickson, the Fisheries Data Manager. We're going to be taking you on a tour of the Fisheries Statistics for 2017. This is Agenda Item 5 and Paper 05. I'll start by noting these are preliminary estimates. We'll be finalizing them later in 2018, although we don't expect many changes from this point forward. Any changes that happen would be just corrections or late fish tickets coming in. I'll remind everyone that the values are in net weight. That's head off, gutted, and washed. And as already mentioned, overall removals have been fairly static over the last several years, with commercial and recreational landings up and bycatch down. That brings our 2017 total removals, including research, to 42.5 million pounds and just over 19,000 tons. Before I get started going into the numbers, I want to review some terminology. We've been working as an IPHC secretariat to be more consistent in our terminology, so you'll see these new terms in our PowerPoints and our reports. The underlined terms are the new terms. So by sector, for commercial, we have commercial landings and then commercial discard mortality. Formerly, this was called commercial wastage. It still includes the same components, which are sublegal halibut less than 32 inches, also called U32 halibut, lost gear, and regulatory discards. For the recreational fishery, this was formerly called sport. It includes charter and private fisheries, and it includes landings and discard mortality, including landings from any commercial leasing. For subsistence fisheries, this was formerly called personal use and subsistence. It still includes the same components as it did previously, which are the 2A ceremonial and subsistence fishery, the First Nations food, social, and ceremonial fishery in British Columbia, the Federal Subsistence Program in Alaska, also called the Shark Card, and then U32 halibut retained for personal use in Area 4D and 4E CDQ fisheries. And finally, we have bycatch and other fisheries, and the numbers we'll report here are our bycatch mortality. These refer to estimates of those fish that die subsequent to capture. Reviewing our total removals between 2016 and 2017, as we've mentioned, commercial and recreational landings are up between 2016 and 2017, and bycatch mortality is down by nearly 400 tons. I will note that we got an update on Alaska numbers for bycatch in January. So the numbers reflected here, the 6.1 million tons, are updated from what appears in our paper 05. And here's a pie chart showing the composition by sector. You can see that most of the removals of halibut are from our commercial fishery, followed by our recreational fishery at 20% and bycatch mortality at 14%. And with that, I'll turn it over to Laura to provide more details on fisheries in each regulatory area.
So beginning with commercial fisheries and moving south to north, in IPHC Regulatory Area 2A under the catch sharing plan, the catch limit is allocated among several sectors. For 2017, the directed commercial fishery was 2% over the catch limit at 104 tons. The incidental to the salmon troll fishery was 3% under the catch limit at 18 tons. The incidental to the sablefish fishery was 49% under the catch limit at 16 tons, and the Treaty Indian commercial fishery was 1% under the catch limit at 196 tons. So 2017 marked the pilot year of observer coverage in the non-tribal directed commercial fishery. This was implemented through Secretariat collaboration with National Marine Fisheries Service, Northwest Fisheries Science Center, West Coast Groundfish Observer Program. 21 trips were observed on 12 unique vessels, and the findings will be reviewed once the data are available. So of note, 2018 is the final year the Secretariat will mail pre-printed applications. Therefore, please mark the deadlines on your calendar. In 2019, no pre-printed applications will be made, and all applications will need to be submitted electronically. So in the IPHC Regulatory Area 2B in Alaska quota share fisheries, the season ran from March 11th to November 7th. In British Columbia, 99% of the catch limit, or 2,809 tons, were landed. In Alaska, landings totaled 8,433 tons, or 94% of the catch limit. The Annette Island Reserve fisheries also occur within Alaska. Thank you. Occur within Alaska, and there's no catch limit, and the 2017 landings totaled 29 tons from 13 two-day openers. Moving on to the recreational fisheries in IPHC Regulatory Area 2A, total landings were 3% under the allocation at 234 tons. And again of note, for the required recreational charter vessel fishing license in this area, all applications must be submitted electronically in 2019. So in British Columbia, recreational landings were 10% over the allocation at 532 tons. The fishery ran from February 1st to September 6th, at which time it was closed as it was estimated that the catch limit was attained. In Alaska, all areas were open from February 1st to December 31st with different management measures for the unguided and guided sectors. Private anglers in IPHC Regulatory Area 2C landed an estimated 649 tons and 841 tons in Area 3A. Landings for the charter sector in Area 2C were estimated to be 0.8% over the allocation at 418 tons. And in Area 3A, landings for the charter sector were estimated to be 10.7% over the allocation at 953 tons. In British Columbia and Alaska, there are programs through which recreational harvesters may lease pounds from the commercial quota share fisheries. In British Columbia, 1.7 tons were landed under this program. And in Alaska, 18.5 tons were landed in Area 2C and 3.1 tons were landed in Area 3A. So moving on to the subsistence fisheries, which run all year long, 530 tons were estimated to be landed coastwide. And bycatch mortality, which occurs in other fisheries throughout the year, removals were estimated to be 2,745 tons in 2017, a 14% decrease from 2016 estimates. So in summary, landings that fall within the applicable catch sharing plans were less than the catch limit for most IPHC regulatory areas. The catch limits were exceeded in IPHC regulatory areas 2C and 3A. So moving on to port highlights. These are the faces of the commission and the various ports we staff up and down the coast. And Jessica Marks, who works with stakeholders in Homer, Alaska, is with us this week. If my pointer works. So this is Jessica here, and she's also at the back of the room, waving. The work they do feeds into the estimates previously presented, as well as into the stock assessment itself. So some of the projects up in the ports, sex marking coastwide was a project that required extensive fleet involvement, and the efforts made by many crew members were invaluable. Dr. Planis and Dr. Laura will report more on this project Wednesday. As in 2018, we will not ask the fleet to sex mark their catch while we develop the essays and reevaluate the continuation of the project. 2017 also marked the first year pot gear for Pacific halibut in the IFQ fishery, sablefish fishery in Alaska. Most of these landings were seen in Seward and Sitka and involved follow-up on regulation clarifications, with many skippers of vessel less than 60 feet requesting training on NMFS logbooks. In 2017, tissue samples were collected from every sampled fish for DNA analysis, and 2017 was the first year for electronic logs in Canada, or the fishing on a tablet, float logs. They were collected in the field via Bluetooth from the captain's device to the port sampler's device, and there were 19 participants. And in summary, the final highlight for the ports is that additional fields were added to Alaska logs in 2017, asking skippers to record the number and species name of any marine mammals that were sighted while hauling. Data regarding the number of hooks or fish damage and the species of fish were also collected for each set. And the Secretariat is working with the contracting party agencies to extend this collection coastwide in 2018. Thank you.
Thank you very much. Good report. Questions or comments? Commissioner Benken.
Or could I ask a question of, I think, of Laura on her report? Actually, I had two. The first was with the recreational fisheries. It looked like we had a consistently overages between BC, 2C, 3A. And I wondered if there was some sort of common ground between that. Were the fish on average bigger? Was there something that you saw across all areas that you think contributed to those overages?
I probably would refer to the contracting party staff on those specifics. I'm not sure right at this point what the average weight was, but that's certainly something I can look up and report back.
Thank you. And then if I could, my other question may also be better answered later, but I was curious to understand how the amount of leasing of commercial quota by the recreational sector, what this year's trends, but this year's quantities, how those compared to previous years. But I can follow up with you, or when we have the report specific to those areas, maybe that will be available.
Yes, we can make that available.
Okay, I'll hold off. Thank you.
Thank you.
Thank you. Any other comments or questions? I see none, so we will move to item number 6, stock status.
Thank you, Chair. And so we have a number of papers to be presented in this section, and I will just pass to Ms. Gowan to introduce the setline survey component. Thank you, Chair.
Thank you, Chair and Dr. Wilson. So we're turning to agenda item 6.1. So we just heard from Laura on the fisheries dependent data collection that the IPHC does, and next up we're going to hear about the fishery independent data that the IPHC collects. Again, I'm Jamie Gowan, the Fishery Statistics and Services Branch Manager, and with me is Tracy Giernart, the Survey Manager. She's going to be presenting the Fishery Independent Setline Survey, and this is paper 06 for those that want to follow along. She's going to provide an overview of the 2017 survey design and implementation, as well as recent and future survey expansions. With that, take it away, Tracy.
Thank you, Jamie. Good afternoon, everyone. As Jamie said, I'm going to run you through a quick review of the setline survey design and the implementation in 2017, and then we're going to look forward to 2019. Oops. Tom. Page up. Oh, there we go. Sorry. Okay, our setline survey is independent of the data collected from the commercial fishery and has been standardized since 1998. There are 27 survey regions with 1,265 standard grid stations. fished each year, and the dots here represent each survey station. Pardon? Arrow. Excuse me for a second. 1 sec. All right, here we go. The standardization includes the gear. We fish fixed gear, 1,800-foot skates with 100 number 3 circle hooks and 18-foot spacing with 5 to 10-pound weights between the skates. Okay, the bait is also standardized. We use exclusively number 2 or better semi-bright chum salmon, and each piece of bait is cut to weigh between 1/4 and 1/3 of a pound. Of course, our primary objectives of our survey is the stock assessment. We gather weight per unit effort data along with sex-specific length at age composition, and the surveys allow us to collect data on undersized halibut as well as track trends in halibut distribution and abundance. We measure all fish. Here's data collection in action. So we measure all fish. We take a random sample of the otoliths, or sometimes called ear bones, for aging with a goal of 2,000 per reg area. We gather gonad maturity in all legal size fish and from any sublegal fish that is sampled for its otolith. And we record hook status and bait status. So new this year, we launched our tablets for electronic data capture, and this occurred in all areas except regulatory area 2A, where we only have 1 sampler, so we can only use 1 paper and pen there. The tablets have improved data quality, the speed of data availability to our stock assessors, which makes everyone happy at that end of the hall, and it saves us data entry time. And we've also had really good feedback from our port samplers who use the tablets. The surveys have also been a platform for IPHC special projects, including oceanographic data collection via the water column profilers, or CCATs, seen here. Ian's doing maintenance on one of them there on the left. Starting in 2009, the CCATs were set on all our stations coastwide. They collect temperature, salinity, dissolved oxygen, pH, and chlorophyll levels throughout the water column. Some of the other projects include genetic sampling, halibut condition factor, contaminant sampling and tagging, and there'll be more detail on the research program on Wednesday afternoon in the admin session with Dr. Joseph Planis, if anybody'd like to hear that. The large geographic area covered by our surveys and the standardization of it makes it a desirable data collection platform for other researchers and agencies. We have welcomed a variety of collaborations. For National Marine Fisheries Service, we are collecting data on peacod, Pacific cod, dogfish, 6-gill and sleeper sharks, and we're also testing electronic monitoring systems on our vessels. We've had a long collaboration with Fisheries and Oceans Canada and the Pacific Halibut Management Association, collecting data and biological samples on rockfish, doing 100% hook occupancy info, and doing some shark sampling. We've also worked with state agencies such as California, Oregon, and Washington, where we are helping collect and sample their rockfish. So this year, 2017, was our most ambitious survey ever. It ran from May 28th to September 20th. We had 12 vessels chartered and completed 1,499 stations, fishing between 5 and 7 skates in each region. We had 27 amazing sea samplers working on our vessels, along with some lucky Seattle staff. This was also our 4th year of fishing the expansion stations. The expansions are meant to fill in gaps in our survey coverage. both deeper and shallower than currently fished, as well as gaps in the current depth zone. So I was going to just run through expansion through the years. So this is 2014. We fished in area 4A and in 2A. 2015, we were up in the closed area in 4E. 2016, we were in the 4D region. And this year, like I said, 2017, we were in 4B, and we fished back in 2A as well. And so before we move on, the dots on these are, you'll see on all the expansion maps coming up, the dots are standard grid stations, and the triangles are the expansion. So, as I said, this year we focused on area 2A and 4B in our expansion. The dots are standard grid stations. I already said that already, sorry. In 2A, we fished 212 total stations with 81 expansion, as well as 26 stations in the densified grid off Washington. In area 4B, we fished 113 new exciting stations for a total of 202. And looking forward to this year, we are in the middle of our station vetting with the various agencies, looking for input from our stakeholders, some of which we've got, and we welcome any more. And we're looking at the feasibility to fish some of these areas. So in regulatory area 2B, we have 103 expansion stations proposed. And in 2C, we have 55 expansions proposed. And so here's area 2B. The blue triangles are our expansion stations. The black dots are our standard grid stations. The green shows up there sort of, yes. The green is, the green and orange are rockfish conservation and sponge reef protected areas. And then there's an orange, the sponge reef bottom contact closure is a tiny dot in Georgia Strait. You can't really see it there, but it's there. Next is, okay, so regulatory area 2C again, the triangles are our expansions and the dots are our standard grid. So looking to the last year of our proposed expansion in 2019, we are planning to move into regulatory area 3A and 3B, where we have 95 and 68 proposed expansions. So we'll be looking to those fishers out there for some feedback on our proposed stations and see if you have any ideas whether or not they're feasible. And lastly, a big shout out and thanks to our various survey vessels. Some of you guys are in the audience. Couldn't have done it without you. And thank you also to our amazing sea samplers shown here. Thank you.
Thank you very much, Ms. Gernhardt, and to the other presenters. Bob.
So, Mr. Chairman, I have a question that goes back to a budget issue we were talking about earlier, and I'm looking at slide 15 that we just had here for proposed expansion areas that are in blue. Yep, that's it. And there was a presumption this morning that the new stations would have a more successful catch rate than the average stations that we currently have. And I'm wondering why that assumption. Is it because these blue dots are where the commercial fleet fishes, or, and you have evidence of that? Or what drives the assumption that the new expansion dots will be more productive than what we've had in the past?
Dr. Wilson.
Thanks, Chair. I think the indication at this morning's meeting was more that the regulatory area as a whole would make more money rather than to offset the costs of the survey, rather than these individual sites, which may actually produce lower catch, they may produce higher catch. We just haven't surveyed them yet. And as discussed this morning, what we intend to do is to put together those figures for you in terms of what the expansion in the various regulatory areas over the next couple of years will look like in terms of cost and benefit. And we'll provide those to you on Wednesday afternoon, if that's fine. Thanks, Chair.
Okay, but Mr. Alden,
Could I follow?
Commissioner Bank.
So if I'm understanding correctly, what your point was then, that the expanded, or the areas with the expanded stations for 2018 are areas with higher catch per unit effort than where we had expanded surveys last year, so you expect a higher return in those areas, is that, or did I misstate that?
No. Thing is, we haven't surveyed these areas before, these particular sites, so we don't know what the answer to that will be. But as a whole, we expect the sites to be at least revenue neutral or slightly revenue positive. But we'll put those numbers together for you for the discussion, the budget discussion on Wednesday afternoon.
Thank you. Comments, other questions? I see no more comments. I think we can move to our final paper presentation before the break, which would be the space-time modeling by Dr. Webster.
Good afternoon. Hopefully you can hear me clearly. I'll be presenting results of analyses involving the space-time modeling in 2017. There are three parts to this presentation. We'll be presenting different aspects of the results for the expansions that Tracy had talked about in regulatory areas 4B and 2A in 2017. We'll look at the output of the space-time modeling in pretty general terms this year, and an evaluation we did on the need for future setline survey expansions in regulatory areas 2A and 4A. So on to the first part of the presentation, the setline survey expansion results. As mentioned, we had extensive expansions in 2 regulatory areas in 2017. In regulatory area 4B, we added some deep and shallow stations, shallower or deeper than we typically fish on our annual survey. We also, more notably, had large coverage gaps surveyed for the first time. These were off Bowers Ridge, the East Andreanoff Islands, and many stations were filled in around Amchitka and between Atu and Kiska Islands in the west. In Area 2A, which has had expansions a couple of times, 2014 was mentioned. We also had a pilot expansion in 2011 in Area 2A. This year we went further south than our 2014 expansion, which went to 39 degrees north in California, and we extended that to 37.75 degrees north in California, noting that motivation for that expansion was that the NMFS Troll Survey has caught halibut down to similar latitudes. So we know halibut are occasionally present in those latitudes. We also repeated the deep, shallow, and Salish Sea expansions that were done previously. And we fished a new dense grid off the North Washington coast, motivated by concerns from stakeholders that the density of our annual survey was perhaps insufficient to miss potential localized patches of high density. This map shows the results on a station-by-station basis for Area 4B. This is a map of O32 weight per unit effort. The area of the circles represents the weight per unit effort. Larger size circles are higher weight per unit effort, as indicated by the legend on the right. So we have some stations which are catching around 400 pounds per skate, and others, as indicated by the X's, similar to Eric's presentation, which caught 0 pounds per skate. The red stations are those that we fish on an annual basis. There are 89 of those. The remaining stations in blue were the expansion stations. As you can see, there are a substantial number of those, and we more than doubled the number of stations in Area 4B in 2017. Turning to the particular results of the expansion, there were quite strong geographical differences in how these expansion stations performed. In the east, in the Andreanoff Islands, we had our highest catch rates in all of 4B, with a number of stations getting close to 400 pounds per skate in the far east of the Andreanoff Islands. And this is our most productive region in Area 4B. Bowers Ridge we had never surveyed before. There were 2 or 3 decent stations in Bowers Ridge. For the most part, we had zero or low catch rates in Bowers Ridge. The remaining stations in the west tended to have lower than average catch rates, which is fairly typical in recent years of the stations we fish on an annual basis as well. Overall, catch rates, with the high catch rates in the east and lower catch rates elsewhere on the expansion stations, were similar to what we have had in the past. And this figure shows time series of 032 weight per unit effort, which is an output of the space-time modeling. In gray with the black line, that's the output from the 2017 modeling, which includes not only the data up until 2017, but we also, as we'll talk about in a moment, added some new data 4 years prior to 1998. In the 2016 modeling indicated in red, which you saw last year as well, we had only used data from 1998 onwards. You can see those lines line up pretty well, only very small differences between them. So the estimates of the space-time modeling was producing in 2016 were relatively unbiased compared to the estimates we're getting this year. Not a lot of bias in that survey, despite the large coverage gaps. We do note that the confidence bounds around those intervals, a measure of the precision of the estimates, are narrower with the addition of the expansion data in 2017. And in particular, I'll draw your attention to the final point, which might be a little hard to see in the distance, but we have very tight confidence intervals in 2017 itself, as this is the year in which we had the direct observations in those areas covered by the expansion. Somewhat different picture for numbers per unit effort. It appears that the estimates prior to 2017 had a somewhat negative bias in that the time series in red estimated last year is consistently lower than the time series estimated this year with the addition of the expansion data. Turning to regulatory area 2A, moving from south to north, we had our most complete survey in California last year. We have fished California previously from 39 degrees north to 42 degrees north. And this year we went to 37.75. We caught 2 halibut this year south of 40 degrees north. One right outside of San Francisco here, and another just south of Fort Bragg. Those are the southernmost halibut we've ever caught on our set line survey. But those very low densities are consistent with the data we had been using previously from the NMFS troll survey to index the area south of 39 degrees north. Between 40 and 42 degrees north, we have catch rates that are similar to what we've observed previously on our expansions in that part of California, which are catch rates are fairly average compared to the area 2A as a whole. So it appears that 40 degrees north is basically the southern limit of non-negligible densities of halibut, Pacific halibut. In Oregon, again, the red represents the annually fished stations. The blue are the expansion stations. In this case, these are all stations deeper or shallower than those we fish on an annual basis. We have high densities off Central Oregon, southwest of Newport, which is fairly typical in the area 2A of Oregon. But we'll notice that as we move north, the densities become lower with quite a lot of zero catch rates in the northern part of Oregon. And that continues into Washington, where we had some very low catch rates in 2017 off the coast of Washington. There's an additional color marking here, symbol, and that's purple, light purple for the expansion in the dense grid design. So north of this horizontal line here, we doubled the density of stations between 20 and 275 fathoms off the coast of Washington. Of greatest interest, or thing that stands out most perhaps, is this area here where we had catch rates of 0 off the central Washington coast. And typically that is not what we see in an average year on our survey. We generally have relatively few stations with 0 catch rates in that area. So why did that happen? Well, the most compelling explanation is this very large and very intense hypoxic zone that established itself in summer off the coast of Washington. And these are data also collected on our set line survey from our water column profilers. This is dissolved oxygen on the bottom in milliliters per liter. And past work by our scientists has indicated that below a level of 0.9 milliliters per liter, halibut tend to be absent. They tend to avoid zones of extreme hypoxia, which is what we observed this year. And that's indicated by the dashed line around this zone here. And that coincides very well with the areas of no halibut catch rate. So this hypoxic zone established itself in summer at the time of and coincided, its presence was coincident with the time of the survey. The survey is doing what it is intended to do here. The halibut avoided this hypoxic zone. That's unfavorable conditions for presence of halibut. And our survey appears to have correctly indexed halibut in that area and shown that, yes, indeed, they did avoid this hypoxic zone. Turning to the time series for 032 weight per unit effort. This is a comparison of the effect, well, this is looking at the effect of those dense grid stations in Area 2A. What effect did they have on the overall index for weight per unit effort, noting that those stations were also affected by the hypoxic zone to some degree. And the effect is fairly minimal. It's greatest in the terminal year. We have the observations in 2017, so it did lead to a slight increase in the overall index for 2A of 2.8%. That's well within the uncertainty in the estimates for 2017, as indicated by these 95% intervals about the estimate. So in space-time modeling more generally, just a bit of a review. We introduced the space-time modeling last year to estimate these indices of density, weight per unit effort, and numbers per unit effort. And previously, we'd used an approach based on direct calculations from the observed data, basically an arithmetic mean with some tweaks and adjustments applied. This method was approved for adoption by the Scientific Review Board, and we've used it again in 2017. The space-time models are still based on the same data that we were using previously, and they reflect, the output of the space-time models reflect what the data themselves are saying, but they're making use of more information contained within this data, specifically about the patchiness of the Pacific halibut distribution. And by using that additional information that we hadn't previously used, we can reduce random variation in the indices. You tend to get a smoother time series than we did previously. They can improve how we deal with incomplete set line survey coverage. We had some ad hoc adjustments in the past, and now the space-time model will make a prediction based on the information we have available, and will lead to improved estimates of uncertainty. In the past, we didn't account for the uncertainty in those areas in which we had not previously surveyed, for example. So the changes from 2017 are relatively small. We included data from 1993 to 1997 IPHC set line surveys for the first time. Those data, those surveys were generally less complete and less comprehensive than the surveys that we currently undertake, but there's still some useful information in most regulatory areas in that time period. In Area 2A, we changed the model that we used previously slightly by adding a covariate, indicating whether a station was north or south of 40 degrees north. We saw from the maps earlier that the densities are very low north of 40 degrees north and substantially higher, south of 40 degrees north and substantially higher north of that. By adding this covariate, we're not going to be changing the estimate we get out of the survey for 2017 much, because we have direct observations for 2017 that give us a good estimate anyway. What it does is it improves the estimate that we would get in years in which we don't have the complete survey coverage that we had in 2017. So past years and going forward, when we come up with estimates for 2018 and beyond, if we don't have the survey expansion in California, this covariate allows us to come up with a better estimate. Otherwise, the estimate in that part of California south of 40 degrees north would tend to drift towards the mean for Area 2A. If you didn't have this distinction, that densities tend to be low and they're built into the model. We also modeled total weight per unit effort in 2017, which we didn't do last year. And the bottom area estimates were updated for all regulatory areas based on the most recent bathymetry data. And I will note that this does not include the request noted earlier made by commissioners for examining an alternative way of calculating the bottom area based on the ruggedness of the bathymetry, not just the. What we do now is basically we're looking at the area of the surface of the ocean. But we'll be exploring that in the coming year, different ways of estimating bathymetry. This summarizes the results of the output of the space-time modeling in 2017. The black lines are the estimates and the gray areas around them indicate the uncertainty through 95% intervals. So we're 95% certain that the true O32 weight per unit effort is somewhere in those intervals in each area. Dr. Steele will be going into these in more detail. I'd just like to make a couple of points. One is that, as we hoped, these estimates are very consistent with the estimates that we got in 2016, indicated by the red lines. Certainly the trends are very consistent, very small differences. We did add, as I noted earlier, data from 1993 to 1997. We might expect that to make some changes in terms of relationships that are built into the model. For example, the relationship between density and depth that's built into the model. But those changes were not large. And so, so that was reassuring. In some areas, it's useful to examine data output model output at a finer scale. One of these areas is area 4CD, which is a very large area made up of a number of components, and some of those components have different trends than others. We note here that, so this is the model output. We note here that the 4C Islands, the Pribilof Islands and St. Matthew Islands have had increasing weight per unit effort over the last few years. By contrast, the edge, 4CD edge, has been stable or relatively decreasing, and the flats have been relatively stable as well. So we have these different trends in the area, but we will note that, so some people who have, their experience might be in 4C or St. Matthew might be wondering why that's not reflected in the overall trend for 4CDE, which is slightly down this year in terms of O32 weight per unit effort. We'll note that, for example, St. Matthew, and this is true of the Pribilofs as well, these are a very small component of area 4CD in terms of the amount of habitat that they occupy. So St. Matthew, which had a dramatic increase in O32 weight per unit effort this year, only represents 0.6% of the 4CD bottom area. And so anything that happens in St. Matthew is going to have a very, very small effect on the overall index, which is going to be dominated by what's going on in the edge and on the flats, which are much larger geographic areas. We also estimated numbers per unit effort. As I mentioned, here's a comparison between the 2016 output and the 2017 output. And again, those values are very consistent. And we model total weight per unit effort as well. And this is a comparison of the total weight per unit effort in blue compared to O32 weight per unit effort in black for each of these regulatory areas. And Dr. Stewart, again, will go into some of these results in more detail. The third and final part of the presentation, we began an evaluation of the need for future survey expansions. This was a request by the commissioners, and we undertook that request in areas 2A and 4A this year. So to do such an evaluation, you need the expansion to have visited these stations. The expansion must have already taken place in these areas in order that we have data in which to make an assessment of. It also helps that some time has elapsed since the expansion took place, so we can see how the quality of the estimates that we've obtained has changed in the years subsequent to the expansion taking place. And here we're using, again, the space-time modeling as a tool to evaluate the effect of the expansions in survey coverage on mean weight per unit effort estimates in regulatory areas 2A and 4A. And I note that this analysis was done prior to the results of the 2017 survey expansion, so we are not making use of any expansion data from area 2A in 2017 in this evaluation. Our approach was to compare models fitted with the data, with all the data, and compare those with subset models fitted to subset to the data, so we can see how, including the areas in which the expansion have taken place, improve the model in terms of its relative error and its precision. And this also allows us to examine how error and precision change with time since the expansion took place, or on the other side, in years prior to the expansion. And in Area 2A, we can examine whether there's an additional benefit of having the 2014 expansion data along with the original 2011 pilot expansion in the areas in which both of those expansions took place. And the details of the analysis are in the accompanying report. I will note, because I don't note it in the remaining slides, the last bullet point of this slide, the additional expansion in 2014 was a minimal benefit. Once the key data point for any expansion we infer from this, our results, is the first time you visit the area. That gives you some baseline data with which to work, which to improve basically all of the components that are being estimated within the space-time modeling and the resulting estimates of the indices. We summarize the results of this, as I said, detailed in the accompanying paper, in a series of recommendations for different components of these two regulatory areas. And this is something we intend to do as we're able to compile more data as the expansions proceed up until 2019, in which we can do a complete assessment of all the areas that have had expansions. So we've broken this into different components. We have the deep and shallow stations in Area 2A, the Salish Sea component in Area 2A, Northern California, noting that we didn't go south of 39 degrees until this year. In 4A, we've broken it into the Aleutian Islands and the Shelf Edge. And here this table breaks things down in terms of the density, whether it's low, average, or high for the different components, the amount of variability, temporal. If there's a lot of variability, you might want to revisit an area on a more frequent basis because the last time you did the expansion, it might no longer represent what the conditions are this year for halibut. We know that in Area 2A, the deep and shallow stations generally have low catch rates, and that was pretty consistent from the two times we did the expansion, so low variability. Salish Sea, we had quite different results in 2011 and 2014. And California is fairly stable, and average variability low between 39 and 40 degrees north, where we basically have had nothing, no halibut. High variability in the Aleutian Islands might indicate you want to revisit that area more frequently. Low variability off the Shelf Edge in Area 4A. So we have some recommendations based on this and some other aspects that we considered in deciding what the recommendations would be. For example, we probably don't need to revisit the deep and shallow waters in Area 2A more frequently than every 10 years. But the Salish Sea, because it's higher variability, every 5 years might be reasonable. It's a relatively small area. It's fairly close to stations we do fish on an annual basis. So updating those data on a relatively frequent basis would seem reasonable. California, at least the component between 40 and 42 degrees north, we'll reevaluate the component south of that once we can compile the 2017 data into that analysis. It is the end of the stock, the southern end of the stock. It's so in that sense, it's marking changes in the distribution from north to south, whether the distribution is changing or increasing in extent. So that would suggest a greater frequency, 3 to 5 years might be reasonable. The Aleutian Islands, it's very highly variable, and the stations that we did expand to in 2014 tend to have higher catch rates on average than those we fish on an annual basis. So a relatively high frequency revisiting of these expansion stations seems appropriate. Whereas the Shelf Edge is relatively low in variability. We also have NMFS troll survey data within that region on an annual basis, and that provides us with an index, at least some information on a year-to-year basis. And we didn't find the expansion area 4A made much of a difference to the in terms of improving the quality of the estimates we got. So relatively infrequent revisiting of those. The final aspect when making a decision, it's not just going to be based on the scientific results of this analysis. We're also the managers are also going to want to bring cost into the assessment. So if you're deciding whether you can do this expansion here versus this expansion, costs might come into play in making that decision. And based on a recommendation from the Scientific Review Board, we've come up with a simple qualitative measure of cost. And this is kind of our first cut at coming up with this kind of cost measure. And so we're certainly interested in the input of commissioners and stakeholders if this is useful or it needs to be refined. So this measure of cost here is the cost relative to other parts of, to the annually surveyed parts of area of the regulatory area. So in this case, the Salish Sea and the deep and shallow stations are relatively low cost. We can, once we're already in 2A, we can fish these stations relatively easily. There's not a lot of extra fuel involved in fishing these stations, for example. Northern California is a little more expensive. We have requirement to land the catch in Oregon, which adds running time and fuel costs to California, for example. Similarly, we have higher fuel and bait costs in the Aleutian Islands, making that a relatively high cost area for the expansion, and the shelf is somewhat lower than the Aleutian Islands in Area 4A. So that's our initial stab at coming up with a cost assessment based on a very simple qualitative criterion to help inform decisions. And as I mentioned, we welcome input on that. And that concludes my summary of the three components of the presentation.
Thank you, Dr. Webster. Comments or questions from the commissioners? Commissioner Ryall.
Thanks very much, Ray. Just on your slide 21, so you're proposing in 2A, which has density low, variability low, and frequency at greater than 10 years. And then under 2A in Northern California, you have it subdivided into two categories above and north and south of 40 degrees. I guess when I look at that row that has Northern California, I thought I heard you say that there were two halibut south of 40 degrees north. And so what's the rationale for having the frequency of 3 to 5 years?
So I'll note that 3 to 5 years frequency is for the component between 40 and 42 degrees north, which is not the low density zone between 37.75 and 40 degrees. And this assessment was only based on the component from 39 to 40. We'll be reevaluating that full data set, including the 2017 data between 37 and 40 degrees north. So I don't make a recommendation at this point for the very low density area in which we only caught 2 halibut. Now we have a more complete picture based on the 2017 survey. So this recommendation for 3 to 5 years is based on California being an area of fairly average densities at the moment. But it's we're also accounting for the fact that this is the southern limit of the stock. If there's going to be changes in the distribution, say there's some climatic effects that make drive halibut north, this is the area we're going to see it first. So it might be an area that's prudent to revisit on a relatively frequent basis. So that's the main rationale there.
Dr. Ryall.
Ray, I guess I don't fully understand that rationale, or maybe I just disagree with it, but I think I would like to know what the overall cost is for each of those rows too for the expansion. It would be helpful to know what that information is as well.
I do have that information. That was Tracy's here. She knows more about this than me. There she is. I don't have it for California. Tracy provided me some numbers. I believe the 2A station costs came out about $2,100 per station. California, Tracy might have some more information. I believe it's somewhat higher cost than that. The Aleutian Islands was substantially higher than that. The Edge was a little bit higher than that $2,100.
Dr. Wilson?
Yes, if I could add to that. Again, we'll put all of the costs for each of the expansions and include the additional information you've just indicated, and we can certainly put that together and provide it to you for discussion on Wednesday afternoon, if that's okay, Vice Chair. Thank you.
Thank you. Any other comments or questions on Dr. Webster's report? Commissioner Alderson.
So Ray, I'm looking at slide 4. It's a regulatory area B. So on the previous slide, it suggested looking at the elutions every 3 to 5 years. So when that comment is up there, are you talking about redoing all these blue X's every 3 to 5 years? Is that what is being suggested?
No, to clarify, that analysis was on regulatory area 4A. So it's the Aleutian Island component of regulatory area 4A only that we're referring to here. We have not done a similar analysis of the data in 2017 because those data were not available, and for area 4B.
So a follow-up, Mr. Chairman. So I'm looking at the right-hand circle there. As we do these expansions, and I'm looking at this, and I'm looking at the eastern portion of that, and which we haven't done much surveying on. Are we picking up additional spots for the annual survey? It seems that in that right-hand side there, there's to pick up a couple of those and add them to the annual survey would be a logical thing to do since we haven't been really assessing that area very often. Are we doing that in the different areas as we get this information from the expanded information?
It's a good question. We are not doing that on a routine basis. The analysis that I did in area 4A indicates that revisiting these areas frequently is relatively frequently. The western part of area 4A is contiguous with the eastern part of the Andreanoff Islands in 4B. Revisiting those frequently is highly desirable. At the moment, the space-time model is able to come up with estimates based on the data we got in 2014 and nearby stations that we fish on an annual basis, and it seems that those estimates are quite good. The quality will decrease as the time elapses since the 2014 survey. There is an argument that can be made that some of these areas are more useful to survey on an annual basis than some of the stations that we actually fish on an annual basis. These are high-density areas, quite likely high variability. Some of the stations we fish on an annual basis don't tend to change a lot from year to year. That's going to be a different component of the evaluation when we undertake a full evaluation as well. There's certainly a strong argument that when we do an evaluation, a full evaluation, we should be looking at not just the expansion areas, but the areas that we do on an annual basis, and deciding which of the stations we should be fishing most frequently and which we should be fishing less frequently.
Maybe I'll talk to you later. There's an echo in here. I'm not picking up everything. It's tough in this corner over here. But the net of it is we're not adding these to our annual grid pattern.
We're not, but we're evaluating how frequently we should be adding them, revisiting them. Yes.
Okay.
Commissioner Benka.
Thank you, Mr. Chairman. I have two questions. One's, I think just because I couldn't hear well from here, but on slide 11, you had DG stations. Can you tell me?
I'm sorry. DG stands for the dense grid. So this slide is a comparison of what the model output is with the dense grid stations, and if we excluded those dense grid stations off the coast of Washington, to see if they had, to see what effect they had on the estimates. And I will note that the final estimates that we did use for calculating IPHCs and that went into the stock assessment included all data, so included the dense grid stations in the estimates that we're making use of this year.
Thank you. One more question unrelated to that. But so I think I understand the way the space-time modeling works with stations within the year. I'm not sure I understand how the space-time modeling is being used to smooth out data from years prior to going back 3 years. And I wonder if you could explain that.
Of course. So there are two components to the space-time model, smoothing components, I suppose. We're modeling spatial dependence, which is how patchy the data are in a given year. We're also modeling temporal dependence, which is how consistent those patches are from year to year. If a station is high in 1 year, is it also likely to be high in the following year or the previous years? How do those patches persist with time. If you tend to have high persistence of patches with time, then you've got high temporal dependence. And that implies that data from last year is also informative about the estimates that you would be getting in the current year, and somewhat true of the year 2 years before and 3 years before, with diminishing relevance as you go back in time year. So we have estimated from the space-time model that there's very high temporal dependence in pretty much every regulatory area. There's a high correlation between the catch rates you get in 1 year and the catch rates you get in the following year or in the previous year. So we make use of that information, that temporal dependence in the modeling. We estimate the strength of that dependence separately for every regulatory area. And by doing that, that effectively adds a temporal smoother to the data. And so you will see, compared to the old way of doing things, which did have a smoother explicitly added after the fact, the series are somewhat smoother than, or consistently smoother than the previous method, because we're now explicitly accounting for that temporal dependence as well as the spatial dependence. Does that help understand it somewhat? Okay.
Thank you. Further questions? I see none. We're scheduled for a break. I have about 10 minutes to 4, so we were going to have 15 minutes. So let's try to come back at 4:05. Dr. Stewart will be up with his portion of the agenda. Thanks. Thank you for getting back. I'm sorry for the aggressive gavel pounding, but it felt pretty good. So let's see, Dr. Stewart, when you're ready, please.
Well, thank you, Mr. Chairman, and good afternoon, everybody. I think we've come to the last item on the agenda for the afternoon. I'll be spending the rest of the afternoon giving you an overview of the data sources, this year's stock assessment, and then I'll get to the catch tables, dividing things out by individual regulatory area at the end of this presentation. For those of you that heard the talk at the interim meeting, I'll be largely presenting the same material I did there, noting that we have had a few updates, and I will stop and point those out where things have changed. In addition, I'm going to make an extra effort to address several of the questions that we got at the interim meeting, as well as questions that I've received subsequent to that meeting in between then and now. I know there's certainly some of the results this year are challenging, and I will make an attempt to focus on questions that I've heard several times. For those of you that are still navigating the various document process we have this year, this presentation will actually cover 4 different documents. The first of those, document 8, is a relatively brief overview of all these results. and I would encourage you to read that one if you've not seen that yet. More detail is provided in document 9. Indeed, much more detail than I have time to go into in this presentation for various data sources, many of which are not directly included in the assessment, but you may find useful in interpreting overall what we do and don't understand about Pacific halibut. Document 10 is the stock assessment, and document 11 is a revision that provides the updated catch tables, including some material that was not available during the interim meeting. So this talk will be divided up into 3 general areas. The first will be the data sources feeding into the coastwide stock assessment. The second will be the modeling and the specific results at the coastwide level. And then finally, I'll get to the catch tables. And I'll start with just a brief summary of the salient results this year. As you will see in this presentation, the most important result this year we find in the setline survey. We saw a large drop in the survey numbers of 24%, and a 10% decrease in the weight per unit effort in the setline survey. And that result is largely driving all the results that you will see across all of the various modeling that we've done this year. Overall, the fishery WPUE was relatively stable. We saw not as much change in the fishery WPUE as we did in the setline survey. However, when we drill into detail, we did see decreases in fishery WPUE in most areas. And I'll speak a bit more when I get to that section about the potential for why that we could see some inconsistencies between the fishery weight per unit effort and the weight per unit effort we see in the setline survey. Another important result this year is that the spawning biomass estimates are actually very close to what we estimated out of last year's stock assessment. So this year, our estimate for last year's spawning biomass is only 2% different than we got last year. The big change this year is the projection, is moving forward in time and see where we're going to be in the next 1 to 3 years. And where we're going to be is that we see much less yield coming into the stock in the near future. And this is a function of lower recruitments moving their way into the various components of the fishery and then finally into the spawning biomass over the next several years. And I've got some additional material since the interim meeting that will, I hope, help illustrate that pattern that we're seeing. So I'll begin by recapping some of the information that was provided in the presentations you saw from my colleagues earlier, but rather than just repeat the same numbers, I'll try to give you a little perspective about what these mean in terms of the stock dynamics and in fact, the stock assessment dynamics as well. So this is a time series of the removals from all sources and all sizes from the Pacific halibut stock. And it also shows you the various components of those removals. And you can see that over time, the diversity of removals from the Pacific halibut stock has grown. We now see an appreciable contribution from discard mortality, from the recreational sector, from subsistence use. And indeed, at the end of the time series there, you see as much distribution among the components as you've seen in any time in the past. You can also see that currently we're sitting well below the long-term average yield from this stock, which is around 63 million pounds. In fact, we've been down in the last few years slightly higher, but not a lot higher than the bottom of the removals time series that we saw in the late 1970s. And this is really a function of 2 things. It's a function of changes in the recruitment, which is the number of fish coming into the stock from each subsequent cohort. And it's also reflective of changes in size at age. As you all well know, the size at age of fish, even though fish were not very numerous in the late 1970s, the size at age was actually quite good. Fish were very large for their age, and that's something that has also contributed to reduced yield in the last several years. You saw a figure very similar to this in one of the earlier presentations. And the additional information I'll provide here is that we've seen changes in the amount of fish that are being utilized as part of the total removals. This year, for the first time, we are seeing 83% of the total mortality actually being utilized, brought to the dock and used in one form or another. And that's an improvement from last year, from 2016, where we saw only 80% of the removals from the halibut stock being utilized. And that's in large part due to a reduction in bycatch, bringing its contribution to the total removals down from 17% in 2016 to 14% in 2017. And I'll come back to that again, but this is an appreciable reduction in bycatch from fisheries that do not target Pacific halibut. And that's, even though the projections for removals this year are down substantially, this reduction in bycatch has actually served to buffer that. It would actually be more extreme had we not seen the reduction in bycatch from 2016 to 2017. Now this table shows you the removals divided among each of these sources, and I thank my colleague Jamie Goen for carefully defining these categories of removals in her presentation. This shows you the trends in those removals over the last 5 years. And the first thing I want to note here is that we received an update from the National Marine Fisheries Service Regional Office, and we appreciate over the last few years we've developed an excellent process for working with them to incorporate the most recent data that's available. And what that means, particularly for this table, is that at the close of the fishing season, in November we have to make a projection about the rest of the fishing season. At the close of the fishing season, the NMFS Regional Office has been providing us with updated bycatch estimates, and these are now going to be included in the rest of my presentation. And as you'll note, there was actually a very small change from their predictions made at the beginning of November through the end of the year. In fact, it was roughly 50,000 pounds additional bycatch in the final numbers than we had in the projection. So relative to many years, this is almost the same number that we've been working with. The bottom line, though, as you see there, is just over 6 million pounds of bycatch, which represents just over a 1 million pound reduction from 2016, and in fact the lowest in the time series since we've been adding up sources of removals outside the directed halibut fishery back in the 1960s. Now what this means is that where we've seen some stability in the commercial landings, they've been fluctuating around 24 million pounds since 2014, increasing slightly through 2017. The discard mortality associated with those removals has actually been going down. So we've seen greater than a 20% reduction over the last 3 years in our estimates of discard mortality from the commercial fishery. So what does that mean? When the commercial fishery landings are going up, but the estimated discard mortality is going down, the implication there is that the commercial fishery is encountering fewer sublegal halibut in their fishing operations. And in fact, that's indicative of what we think is going on in the stock overall, which is fewer, smaller, younger fish coming into the stock on the heels of a relatively decent year class born in 2005. I've already made the point about bycatch, so I think I'll move on now to the next slide. You'll notice in the documentation this year a relatively new concept. Well, in fact, it's not a new concept. The concept of biological regions is, in fact, a historical concept for the Pacific halibut, for the management of Pacific halibut. In fact, the numbers that indicate the different regulatory areas were part of a regional concept for the Pacific halibut stock that was used historically. And in being directed by the Commission at last year's annual meeting to revisit our rationale for how we estimate the stock distribution and really how we interpret the stock dynamics, the staff, in looking at the information that we have at hand, concluded that it makes more sense to be thinking about the stock in terms of biological regions rather than trying to force the management lines between the individual regulatory areas, which were really drawn for management purposes and not for the purpose of defining the biology. So what you'll see in this year's documentation, and indeed in my talk here, is an acknowledgement of both of these components. So first, that we can see perhaps more clearly biological patterns and stock trends when we look at the biological regions, but recognizing that we still have quota divided by individual regulatory areas, and we still need to get down to the resolution of individual regulatory areas for interpretation of how this is going to influence quotas and, in fact, for decision making. So we're trying to provide not less information this year, but more information. Information at the level that's important for the biology as well as that's important for the management. So along those lines, I'm going to begin presenting each data source generally by region, and then I'll move into the individual regulatory area. And I'll begin with the survey weight per unit effort, the legal weight per unit effort, or O32. And here, this is a figure that shows you each of those biological regions and the trends that we've seen since 1993, noting that my colleague, Dr. Webster, was able to include the longer time series in this year's analysis. So some of these data in the early part of this time series we've not seen before. The first thing you can see when we consider these trends at the regional level is that the trends are much smoother than we see at the individual regulatory area, because some of the error in observing the stock, as well as some of the variability in fish moving among individual regulatory areas, is dampened out as we begin to aggregate those into regions. So you see a smoother time series here. I will note on this figure, this shows the legal weight per unit effort, and each of these panels is zoomed in on each region. So the y-axis is different. So the same change in each of these panels doesn't mean the same thing for the stock. But overall, you can see a very comprehensive trend here, which is that we saw decreases in the legal weight per unit effort across all of the biological regions. And those translated into an aggregate at the coast-wide level of a 10% decline in weight per unit effort at the coast-wide level. And that's the largest decline we've seen since 2012 to 2013. Really, this keeps us on a relatively flat but slight downward trend since around 2010. If we then zoom in a little bit more farther into the level of individual regulatory areas, we start to see instantly the additional variability at each of the regulatory areas, and some of the differences among these areas start to jump out. You'll see in the upper right-hand corner there, Area 2C saw a 1% increase in legal weight per unit effort, and that was the only area that we saw an increase across the entire coast. There were 3 areas that showed substantial decreases from 2016 to 2017, and these percentages in the corner of each of these plots reflects the percent change from 2016 to 2017. Noting that areas 2A, 2B, and 3B all saw the largest declines that we see in this time series. Now, one of the questions I've received several times since the interim meeting is this level of change biologically plausible? Should we be looking at this and thinking, well, maybe it's just sampling variability, or is this a reasonable level of change? Is this something that we've seen before or is plausible for the dynamics? And I would encourage you to consider 2 things. One, when we back up here to the regional level, we saw this downward trend across all the regions. This was not isolated to just 1 or 2 regulatory areas. In fact, we saw signs of decrease across all regions. The second thing I would point out is if you look back through these time series, and you note that we have some great tools on our website now to investigate this further. What you can see is that for all of these regulatory areas, we've seen declines of this magnitude in the past. These are not unprecedented declines. If you look back through each of these time series, you can find years when we saw declines of this magnitude. Now, in some cases, those declines were reversed in the subsequent year's survey, but in many cases, particularly in areas 3B, 4A, 3A, you saw declines of this magnitude that were not reversed in the subsequent year's survey, that do appear to have been actual declines in the stock as we look back now with the benefit of hindsight. So I would say in answer to that question, declines of this magnitude are biologically plausible, particularly when we consider these trends at the regional level. Moving now into the numbers per unit effort. So this is numbers per unit effort of all sizes of halibut. And the first thing that jumps out here at the regional level is that essentially the percent change is roughly doubled from what we saw in weight per unit effort. We saw a more dramatic decline in numbers than we saw in weight per unit effort. And that raises another question that I've had several times, which is how can that be? How can we see such a big difference in numbers per unit effort and a more modest change in the weight per unit effort? And the answer to that lies in the age composition data. The way this is consistent between these 2 time series is that the biggest change in numbers occurred in the smaller, younger fish, which are not contributing to the legal weight per unit effort. So again, this is going to be one of the most important results of this year's survey time series, which is that the declines we saw have largely occurred in the youngest, smallest fish. And we've not yet seen the full effect of that, and I'll speak more to that later on. Now zooming into the level of individual regulatory areas, again, this is still numbers per unit effort of all sizes of halibut. The same 3 areas jump out as having the greatest amount of change from 2016 to 2017, but noting now that the degree of change is larger than it was in legal weight per unit effort. Now, my colleague, Dr. Webster, showed you some detail about one of the potential mechanisms we think may have been influencing the time series in Area 2A, and that was the hypoxia event that occurred off the Washington coast. So that may have been a contributor to the setline survey decline in Area 2A. I'm going to move now into stock distribution. Now, stock distribution is calculated directly from the results of our set line survey. It is, in fact, historically, we have used only the 032 survey trends to calculate the distribution of the stock. And so what you see here is the percentage of the stock from 1993 to 2017 occurring in each of those biological regions. So each of those blue bars adds up to a percentage of the stock, and all four of the bars collectively in each year add up to 100%. And the first takeaway here is that you can see most of our stock occurs in region 3, and historically even more of it occurred there. We saw a shift over the last couple decades from a relatively high amount of biomass in region 3 to a lower level in recent years, with over the last 5 years, despite the fact that we saw a big decrease from 2016 to 2017, actually the stock distribution has stayed relatively consistent. And that's because we saw that decrease across all of these regions. Conversely, if you look down in the bottom right-hand corner, you can see that that decrease in region 2 has corresponded to an increase in region 2, the decrease in region 3 has corresponded to an increase in region 2, which appears to have stabilized at a fraction of the overall stock that's higher than we've seen since the survey design was comparable in 1993. Now, I would love to have a longer time series to be able to go back, not to 1993, but perhaps to 1953 and examine how the stock distribution has changed over that time period. However, we just don't have the degree of standardization in our set line survey data in years prior to 1993 to be able to do that. So this is indeed as far back as we're going to be able to go. An additional piece of information that we're also providing this year is not just the distribution of the 032 stock, but the distribution by weight of the entire stock that we see with the set line survey. And this corresponds generally to the 026 stock. And if you've looked at the current harvest policy or management procedure in detail, you'll note that there is a slight inconsistency in there, which is that we have been calculating the stock distribution based on 032 observations in the survey, but yet when we go to distribute the removals, we're distributing 026 removals. So in fact, this year, we're now providing both sources of information for your comparison. And you'll find in the documents, particularly in the back of the data overview, you'll find tables of these percentages of stock distribution, both by the region and by individual regulatory area for your comparison. Now, if we do zoom down into the level of individual regulatory areas, you can see right away that there's more variability. So you see particularly for area 3A, where we had a relatively smooth curve here over time, which appears to be capturing trends in the population, now you see much more interannual variability. You see years are up, years are back down. And what this means is this translates into increased variability when we go to use the stock distribution to then think about how to distribute the catch subsequent to that. And so the cost of moving all the way down to individual regulatory areas is in fact this additional variability that we see in this plot. You can also, on this plot, very quickly see the relative contribution to the coastwide stock of each of the regulatory areas. Discounting the trend over time, which is most prominent in area 3B, you can see the relative magnitude of the stock occurring in each of the areas, with the smallest fraction in area 2A and the largest in area 3A. You can also see for area 4C, D, and E that we've seen a general increase over the time series in the contribution of area 4C, D, and E to the overall stock. I'm going to move now into the commercial fishery data. And there's several important things to point out in this year's results that differ from previous years, and an important question that we need to address after I introduce these three concepts. So these three concepts are, first, we've provided in area 2A a delineation between the tribal and the non-tribal trends observed in catch per unit effort from the commercial fishery. And I'm going to zoom in on that so you can see it a little better. The blue represents the tribal fishery and the tribal fisheries, and the green represents the non-tribal fisheries. And what's important to see here is the very different trends we're seeing from these two time series. Indeed, the tribal fisheries, which occur off the northern Washington coast and into the Salish Sea, have actually been increasing in their catch per unit effort over the last 3 years. Conversely, over that same time period, we've seen the non-tribal fisheries, which they're in fact the last derby fishery on the coast, and occur largely off the Oregon coast. This catch per unit effort in that fishery has declined over that same time period, relatively stable from 2016 to 17, but stable at some of the lowest levels we've seen in the entire time series. So previously, by aggregating these two series, I think we were losing sight of some important information that we're trying to do a better job of showing you explicitly here. The next important observation from this year's results from the fishery are the trends that we see in areas 4C and area 4D. Both of these areas showed a big increase in fishery performance, in weight per unit effort from the commercial fishery. Particularly area 4D, which was up 67% in their catch rate from 2016 to 2017. And as you saw in the earlier presentation from the setline survey results, this is in fact entirely consistent with what we saw in the setline survey, which was up a similar magnitude in the area around St. Matthew Island. And in fact, when we look at the area 4D catch rates, what we see is that from 2016 to 2017, an additional 25% of the catch shifted from the 4D edge to this area around St. Matthew Island. And that, in combination with the increased density of fish around St. Matthew Island, leads to this large increase in the observed weight per unit effort. The last change, or the last important thing to note about the analysis of this year's commercial weight per unit effort is the correction for incomplete logbooks. And what do I mean by that? Well, each year, when we summarize these data in November, we only have a subset of the logs that will ultimately be available for this fishing year. Some of those logs occurred late in the season and are not yet available, and some of those logs are on vessels that we didn't sample at the end of the year, and they'll either be mailed to us by the vessel captains or owners later in the year, or we'll pick those up through port sampling this following spring. Now, in a perfect world, or in an ideal world, those missing logs would just provide a little bit of variability. We would get those logs in, and sometimes the answer would go up, and sometimes it would go down, but it wouldn't have a systematic trend. Unfortunately, what we've seen over the last 5 years, as I've analyzed these data, each year I go back the subsequent year and look, and in many regulatory areas, we've seen a decrease in the post-season logbook trends than we saw with the data available. So we presented this information in some detail to our scientific review board this year, and they encouraged us to develop a bias correction, or an estimate of if past years are a good indicator, what would we expect to see from the commercial fishery when we get the rest of the logs? So what you see on this figure, the percentages there indicate the percent change from 2016 to 17 for the logs we have right now. In red, I show you the percent change that we would predict when we get the rest of the logs. This is what we will likely see when the rest of the logs come in. And you see in many of the regulatory areas, particularly pronounced in Area 2, is that the postseason logs generally revise these estimates downward. And in fact, if past years have been a good indicator, we can expect that there was a downward trend across all of Area 2 in the commercial logbooks. Now, is that for sure? No, I can't tell you that's for sure, because these are variable. They do vary year to year. However, with the last 5 years as our predictor, that's what we would estimate to happen next year when we go back and look at these logbook trends. Okay, with those 3 observations now, leads to the question, so what did we see in 2017? And focusing on the red numbering here, which is our best estimate of where we're going to end up, looking at the bottom right-hand panel, we see that the fishery actually increased by 3%, where the setline survey, the legal weight per unit effort in the setline survey, was down by 10%. You can see some pretty important differences among the regulatory areas, particularly those areas 2A, 2B, and 3B, where we saw the most dramatic declines in the survey, yet we're seeing declines, but relatively small declines in the commercial fishery. And so that leads me to another question that I've received several times during and subsequent to the interim meeting, which is, how can we reconcile these different trends between the commercial fishery and what we're seeing in the legal weight per unit effort in the setline survey, which at face value are relatively comparable? And the answer to that lies, and we see this illustrated in several different areas, in the spatial distribution of the survey compared to the spatial distribution of the fishery. What we've seen over the last couple of years, particularly from 16 to 17, are differences. The bulk of the catch are coming from in the fishery relative to where we're seeing it in the setline survey. And you've already seen an example of that in area 4D, where you saw the set line survey is largely driven by the density on the Bering Sea shelf, but yet the fishery is generating most of its catch in some small areas around the Pribilofs and around St. Matthew Island. Area 2A, in fact, is a similar example where the tribal fishery is operating off the northern Washington coast and inside Salish Sea, and in fact operating at a different time of the year than the set line survey, so both a spatial and a temporal difference. Another example that I haven't yet shown you the detail on, but I could get to that if you'd like to see it later, I have it in my extra material, is in Area 2B, where the declines in the set line survey actually occurred in only 2 of the 4 charter regions. The 2 northern regions, which is in fact where the bulk of the commercial fishery occurs, actually showed a small increase in survey weight per unit effort. But yet the 2 more southerly areas is where the dramatic decrease occurred in our set line survey results. And that's in fact where not very much of the catch historically has come from the commercial fishery in Area 2B. So it appears that much of the discrepancy between these series is due to spatial patterns. And those appear to be becoming more pronounced. And I think that's the open-ended question, is what is it about the stock and the stock distribution within regulatory areas that is creating either the incentive or the ability for the fishery to target areas that are apparently becoming smaller relative to the overall footprint of the stock that we see in the set line survey. I'm going to move now into the biology, and the first biology slide is the average weight of a fish landed at the dock in each of the regulatory areas. The black line down the middle here shows you the coastwide aggregate average weight, and you can see that line has gone from a little over 30 pounds down to something in the low 20s, and that's largely a result of the change in size and age of fish. However, this figure is combining 2 different sources of information. It's combining size at age, but it's also including the age composition of the catch in each of these areas. However, even though it's combining 2 components, I think it's important because this is what many of you are seeing when we're seeing fish landed at the dock, which is how big are those fish when they come over the rail at the dock. And you can see that over the last couple of decades, Area 2C, the red triangles across the top there, has consistently landed the largest fish on average on the coast. And in fact, not just Area 2C, which is obvious because it's on its own up there at the top, but several regulatory areas showed an increase in weight, in the average weight of fish landed from 2016 to 2017. Now that's a good thing. That's a bigger fish coming to the dock. But what that also is indicative of is fewer small fish in the catch. So where we've had many fish that were just above the legal size limit, we're seeing a slight increase in age and size of those fish. And again, that's indicating this lack of smaller fish coming behind them. I'm going to move now into looking at the age distribution. And the age distributions, as I've said several times now, are one of the key outputs of this year's data. And so I'm actually going to show you the age distributions in 3 different ways, 2 of which are in the documentation and a 3rd of which is more of a graphical way. But I hope by showing you this using 3 different methods that I can help you better see. Hopefully one of these methods will make things, will be a little more clear and help you see what the patterns have been over the last few years in the age compositions. So the first try here is the bubble plot. And what this shows you is that the percentage in numbers of fish at each age in each year of our set line survey. Again, this is just data. This is not stock assessment modeling. This is just data. And you can see a couple things. Strong cohorts show up as diagonals. So here's our 2005 year class, which is currently the most important year class in the fishery. And here's the 1987 cohort, which is the most important year class in the history of the fishery. And it's useful to be able to see both of those on the same graph because we can compare how the magnitude of the 2, and you'll see I'll do this several times to see just how big that 1987 year class is compared to other year classes. What's important and what you may or may not be able to see in this figure is that at the end of this time series, the bubbles below that red line, or the age classes that are younger than that 2005 year class, have been a little more sparse than the year classes of those ages previous to the 2005 year class. Now, I think I presented a similar figure to this at the interim meeting, and I think it didn't work for everybody. So here's another way to see the same data. this is a figure showing you the numbers per unit effort at age. And so this is not just the proportions at age, but actually the magnitude of catch that we saw in the set line survey. And those same diagonals are present. That big pyramid at the back of the graph in 1997 is showing you the 1987 cohort. And you can see that cohort walk forward toward the front of this graph and decline over time. You can see the importance of that cohort. On the bottom left here, in the last several years, you can also see that 2005 year class moving forward. And it's the peak in the blue, and then the orange, and then the gray. And you can see that peak moving forward. And perhaps a little more clearly in this figure, you can see the lack of fish coming along behind that 2005 year class. Now, I confess, this figure actually doesn't work very well for me. So if this figure doesn't work well for you, I'll give it one more try. And that is by not showing you the trend over time, but by showing you the trend by cohort. So I've taken the same data I showed you in the last figure, and now I've cut it up by individual cohort or individual year class. And you see standing off the top there is the 1987 year class. So what I'm showing you across the bottom is the age of a fish, and the y-axis is the numbers per unit effort of fish associated with that age and that particular cohort. Now you might be thinking, well, why does 1987 start at age 10 at the top of the graph? Well, our survey time series of age starts in 1997. So the first observation of ages we have is when that year class was 10 years old. And you can see that throughout its entire lifespan, all the way out to age 19, it was the most numerous cohort we've ever seen. And in fact, that 1987 cohort provided over 200 million pounds of removals by itself to the directed fishery. No question, the most important cohort in the history of the halibut stock. Now, I've aggregated here initially all the other cohorts just to set 1987 off by itself. But if we now look through the time series, and so now I'm gonna gray out some of the cohorts, and the lines that are in red are showing you individual years, individual windows of years. So if we look first at 1979 through 1998, you see a variety of different cohorts, some of which we didn't observe all the way down at age 5. We picked them up later in their lifespan. Some small ones, some big ones. Remember, right in the middle of this was the 1987 year class. So we have a mix of medium and small and medium-sized year classes, and then one big one right in the middle. We move forward to 1999 through 2005, we had some decent cohorts in there. The red here shows you those cohorts. But remember, we didn't have that 87 year class right in the middle of all this. So the amount of yield that was available from these cohorts was substantially less than the period before, because we didn't have that one giant one right down the middle. Now, from 2006 to 2011, you see all of those lines are in the bottom half of this graph, indicating that these cohorts are all, at least out as far as we've seen them, not looking like particularly strong cohorts as they come in. Now, this is a great place to bring up another question that I receive frequently, which is, why don't you do a better job of predicting recruitments closer to the time we're interested in them? So I want to know about the 2012 and 13 and 14 and 17 year classes. Well, the 2011 year class shows up on this graph as just a line between ages 5 and 6. The 2012 year class, if I put it on here, would just be a dot at age 5. And that's the challenge we have. Our survey, that's the lack of information. That's the window that we get from our survey only gives us this resolution of information. So those subsequent year classes are out there, they're in the water, they've been born, they have a year class strength, and we have yet to be able to estimate that year class strength through the set line survey data. Believe me, I would love to know better the recruitment subsequent to 2011 to be able to give you a better forecast of what's coming up over the next few years. Okay, the last section for the data portion of this presentation is with regard to conditions in the ecosystem. And this is something that's we've added this year, and I think this is probably a good year to start considering what's going on in the ecosystem. As many of you know, the last several years have been very atypical, particularly for the Gulf of Alaska, but also for the Bering Sea and British Columbia and the lower 48. We've seen warmer waters. Everybody's probably heard of the blob of warm surface water in the northeastern Pacific. Well, that in fact turned itself into warmer waters even into the deeper parts of the Gulf of Alaska subsequently over 2015 and 16. We do appear in 2017 to have gone back to some cooler temperatures there. We saw an influx of gelatinous zooplankton, which is just nasty stuff that no one's ever seen before, that's generally relegated to the subtropical areas. Those showed up all the way up into the Gulf of Alaska. We've seen an increase in seabird die-offs as well as whale strandings. Now, we don't know what all this means for the Pacific halibut stock, but the changes are large enough that I think it's worth considering as we evaluate where we are and what we think is going on with the Pacific halibut stock. And I'll bring in a couple observations from just a few other species that really caught people's attention this year. The first being Gulf of Alaska Pacific cod, which the survey, as well as this year's quota for the fishery in the Gulf of Alaska, was down roughly 80% over the last couple of years. That is a huge change in the cod abundance in the Gulf of Alaska. And that's been attributed largely to that warmer water extending into deeper zones, causing an increased metabolism in the cod stock. And that, combined with a lower forage base due to the warm water, apparently has created a higher mortality rate on cod over the last couple of years in that area. In addition, we've seen decreases in arrowtooth flounder biomass measured by the NMFS trawl survey in the Gulf of Alaska. One bright spot in this story, with all things changing, is that sablefish appear to have experienced a great year class in 2014. It's still early to estimate the ultimate magnitude of that year class, but it appears to be one of the biggest ones in some time. So change is not always bad, and I certainly don't know how it's going to translate to the halibut stock. If you're interested in more detail on this material, I note that I'm drawing largely from work done by NMFS through the Alaska Fisheries Science Center, and documentation provided to the North Pacific Council. And through both of those organizations, you can find much more information about these patterns in the last few years. Now, what are we using, and what is perhaps most relevant to the Pacific halibut stock is changes in the Pacific decadal oscillation. As you may know, we use this because historically this has been correlated to the recruitment strength of halibut. When we see a positive phase of the Pacific decadal oscillation, on average, we see better recruitment to the Pacific halibut stock. And in fact, we estimate that correlation inside the stock assessment models, and it has held up over the last almost 20 years now since this relationship was identified. It's not a causation, it's a correlation. We don't know why this is the case, but historically these things have been correlated. And what's important is two things. First, we appear to have seen with this warmer water some positive conditions. 2013, 14, 15, 16, and 17 all appear to have been positive years, noting that we don't have a way to corroborate what's been going on in recruitment over this time period yet. We're still waiting to see direct evidence of those recruitments. However, this period from 2007 through 2013, historically, the PDO condition would suggest that those would have been below average recruitments. And as we've seen in the previous plots, that appears to be consistent with what we've seen so far in those year classes, noting that some of those are still relatively uncertain, given that we've only seen them 1 or 2 times in the setline survey. So with that summary of the data that's available to us, I'll now move into the modeling and the results from that modeling for this year. Noting that we are a little bit behind schedule. I think I was a little bit behind when I started, so I probably will run over a bit on the original schedule, but I do want to get through the material that I have here. So moving now into the modeling. As many of you remember, 2012 was a year of relatively rapid and challenging model development. We were unraveling some technical problems that had plagued the stock assessment for a number of years. And indeed, through 2013 and 14, we saw a period of relatively important improvements in the models that we were using at that time. In 2014, we finally landed on 4 models across of how we treat the spatial information and how we treat the historical data. And in 2015, we did an in-depth, independent scientific review using our scientific review board of those models. We got right into the details of residual patterns and all of the various data weighting and components of these models. And we've settled on these 4 models during that review. Not just the models themselves, but also our method for aggregating those models into the ensemble of results that we provide each year. Importantly, since that 2015 independent scientific review, we have just updated or improved the data sources. We've not made structural changes to those models. And so I provide you the reference document there if you'd like to go back and see the technical details of these models. The technical approaches remain unchanged from that 2015 review. What we've done in the meantime is to incrementally improve the data sources as new information has become available and as these time series have gotten longer. And so for 2017, what that has entailed is several important improvements to the data sources. The first was an addition of ages from the survey expansions that we've conducted over the last several years. The second was a move toward using measured fish weights. Our port samplers are now actually weighing individual fish rather than relying on the length-weight relationship to estimate weights of those fish. And the third is to begin including prior year's logbook information, even if it comes in after the current year. So previously, if we got a 2 or 3 year old logbook during routine data collection, we would not go ahead and update our databases to account for that. This is a very small fraction of overall logs, but this is allowing us to essentially use the best information, the most complete information we have available. Now, those changes were available for our scientific review conducted in June this year, and I presented the results of that. And that was just a small positive effect on the stock estimates, only a 3% change after all of those changes were made to the stock assessment models. And you can check that reference there if you'd like to see the individual details for those 3 changes. Now, subsequent to that June review, we had 2 more components that we could update for 2017. The first, as you heard in the previous presentation, was that we now have survey time series information available from 1993 through 1997. So that's included in this year's stock assessment. And then the last one is the normal and routine updates where we update the 2016 information using post-season data, and we add the 2017 information as complete as we have at the time of the stock assessment. And what does this all mean? Well, this plot shows you a time series of the spawning biomass, and the results of each of the last 5 stock assessments are black lines terminating in a red dot, which was where we thought we were at the end of each of those stock assessments. The blue, the shaded region, shows you down the middle, the blue line shows you the median value from this year's ensemble, and the range, the shading of the blue, shows you the relative credibility interval from this year's stock assessment, showing that all of the previous year's results are right in the middle of that blue zone, meaning they are consistent with the results from this year's stock assessment. This year's stock assessment is in fact slightly lower than some of those red points, but not only is the scale very similar, but the trend is quite similar as well. All of these results have indicated that the stock was generally through about 2016 or 2017, and then turned the corner, and 2018 is the first year that we've actually seen a slight decrease in the spawning biomass since around 2010. So really no big change to the spawning biomass time series this year. And I'll get back to why you're seeing bigger changes in some of the other time series when you're not really seeing a big change in this figure. First, I want to drill into some of the details of the individual model outputs from this year. This is the time series of estimated recruitments from each of those 4 models. And you see that although not all 4 models are on exactly the same scale, that's because we're dealing in age 0 recruits, and there's a substantial amount of mortality occurring in some of these, particularly the series at the top there, before they all get to the same age where we start to see them. The point here is not so much the scale, but it's the trend of these recruitments. And you can see quite clearly that the 1999 and 2005 year classes are estimated to be the strongest year classes in recent years. And then subsequent to 2005, we have somewhat lower year class strengths estimated for 2006, 7, 8, 9, and 10. Now, let's put those in context for a second. So here, I'm actually going to dip back to the data for just a second and show you, and I'm only going to show it to you once, one figure here for the fishery ages, which is the bubble plot. But this is the same data I showed you for the set line survey, except this is now coming from the commercial fishery, and it's the proportions at age from the commercial fishery, noting that you see very few 5, 6, and 7-year-old fish that were present in the set line survey, because those fish are still largely sublegal and don't show up in the landed catch. However, the important takeaway from this figure is that the bulk of the commercial landings in numbers come from fish that are ages 9 through 18. This has historically been the backbone of the fishery all the way back into the early 1900s. In fact, over this time period, 86% of the landings come from that age range. Yeah, we see older fish, we see a few younger fish, but the vast majority of the landings come from fish that are ages 9 through 18. Now, what's important about that, if we now get back and look at these recruitments, well, how does that age range of 9 through 18, how's that feeding into the fishery? And these estimates, as they move into the fishery, what do they mean for upcoming fisheries? So in 2016, you'll see that age range of 9 to 18 only included 2 of those lower recruitments. And they would have been only the youngest recruitments. They would have been the 9 and 10-year-olds in the 2016 fishery. In 2017, we're now capturing 3 of those recruitments, but we're still getting the 99s and we're still getting the 2005s. And this is an important point here. As we project forward, 2018 is the first year in which we lose the 1999 year class out of the bulk of the fishery. So there's a chunk of our yield that's slowly disappearing and moving out of what's contributing to the fishery. And now, 2018, we're now up to 4 year classes coming from this period of lower recruitments at the end of the time series. By 2019, we're seeing almost half of the recruitments, or almost half of the fishery will be covering these recruitments that we are currently estimating to be lower than anything we've seen in the subsequent period. So that's why you're seeing, as we move forward, you're seeing much more pessimistic forecast of yield 1 year and 2 year and 3 years out than you're seeing in terms of our stock size estimate right now. That's going to be the effect of these year classes moving into the commercial fishery as time goes on. And getting back to my point earlier, we still have a great amount of uncertainty about those year classes from 2011 onward. These are year classes that are only very weakly informed by the set line survey. Now, I'll make the same point again in one other way. This shows you the breakdown of the individual stock assessment models in terms of spawning biomass. And you can see that all of those models are projecting for the first time a slight decrease at the end of the time series, or in the case of one of those 4 models, a relatively flat time series. I think it is actually a slight decrease. It just doesn't look like it there. But for the first time since about 2010, we're projecting a slight decrease in spawning biomass across all of these models. And the data this year were very informative for 2 of these models, the areas as fleets models, which had subsequently or previously been projecting a slight increase even through 2018 in last year's results. That low survey point has informed particularly the upper end of the distribution of our results this year. Now, this is the spawning biomass, but that doesn't correspond exactly to what we see in the set line survey or in the commercial fisheries. So here's another way to think about the stock trend. These are the trends from each of the 4 models couched in terms of the age 8+ biomass. And I don't have a readily available variance estimate to go with this, noting that there is uncertainty about these curves. I just don't have a rapid ability to plot it here. But here you notice where we're seeing just 1 year turning over in the spawning biomass, you see now several years of decrease in the 8+ biomass. And that's indicative of capturing some fish that are younger than those fish contributing to the spawning biomass. So as the recruits are coming up, they're going to influence the 8+ biomass before they're influencing the spawning biomass. So let me put that one other way. If we think about the age of a recruit or a year class, as it moves through the stock, it's going to be roughly 11 or 12 years old before it starts contributing to the spawning biomass. However, it's going to be contributing to the 8+ biomass from age 8 onward, and that's a pretty good proxy for what's going to be available to the fishery. And now thinking in terms of the effect on total mortality, it's going to be contributing to the SPR, or our measure of fishing intensity, all the way from age 2 onward, because age 2 is essentially where these fish start to experience mortality from fishing sources. So that's why you're seeing different trends in these different sources of information. As we look at projections, we're getting the scale of those projections from the SPR, which is actually referencing those year classes that are even before they're coming into the fishery. And the fishery is capturing information from year classes before it gets to the spawning biomass. So that's how there can be this much difference between a relatively flat spawning biomass trend and what we're projecting for yield in the upcoming year as a fairly large reduction. This gets me to a summary of this year's results. And I'm not going to spend a lot of time on this. This is provided in the documentation, but I want to make a few key points. The first is that the overall mortality has been relatively stable at about 42.5 million pounds. The second is that we estimate that 2017, the mortality was in excess of the reference level. There's a 75% chance that we were fishing at a level of intensity greater than our reference level. And in fact, that's no surprise. We projected that from the catch limits that were set last year, that would be in excess of the reference level. And there was a high probability of stock decline associated with those catch limits. The next point I want to make is with regard to stock status. We currently estimate there's only a 6% chance that we're below that reference point of SB30. What does that mean? Well, that means that we are not yet at our reference points. We still have a buffer between where we are now and our SB30 reference point. We are still comfortably above that level. The last point I want to make here is that despite the changes in the stock, and in fact, the big change we saw from 2016 to 2017, the stock distribution, whether we measure it with O32 or all sizes, has been relatively stable over the last 5 years. And that would seem to indicate that the mortality and the movement and all the other factors influencing the distribution of the stock have led to a relatively consistent distribution across the biological regions over the last several years. So I'll now move into the harvest decision table, which is our picture of where we're going to be going over the next few years at the coast-wide level. And there have been a few changes to the harvest decision table this year. The reference level is based on SPR rather than the old blue line, which was based on eBio. That's an important improvement. The orientation of the table has changed, and we've provided a bit more detail in the table. So I think you'll see there's some new metrics in there. We filled in, instead of just year 1 and year 3, it's now all 3 years, so you can see a smoother change in the probabilities. But the thing to remember is that the basic way in which we're calculating this table has not changed. We're just providing a bit of additional information to go with what you've seen in the past. So the basic way this table works is that you have benefits across the top, which are different levels of removals, and you have risk down the bottom. And each row corresponds to a different metric of risk. So you can decide for yourself which metrics you think are most relevant, and you can see how the probability of those risks changes over a range of different catch levels. So if we zoom in on the top then, you can see quite clearly that the reference level is right down the middle of the table. You should instantly be able to find that reference level, which represents an SPR of 46%. And I will note that that reference level is in fact a higher level of fishing intensity than historically the blue line represented. In last year, when we compared these two things, the blue line was indicative of an SPR of 48% and the reference level 46%. And what that means is that the reference level is a slightly higher level of fishing intensity than we had been seeing as our reference in this table when we used the blue line in the past. Now, at that reference level, if we look at a 3-year projection here indicated in purple, you can see that we would project the stock to decline, but only slightly the next years. Removals that will more or less stabilize the stock at its current next 3 years. If we look now on the far left-hand side of the table at no removals at all, well, how fast could the stock increase if we didn't take any fishing-related removals from the stock? And here you see that the halibut stock is capable of increasing. However, it's not going to increase back to levels that we saw in the early 2000s over a 1 to 3 year time period. This represents essentially as fast as the stock can recover with no fishing mortality whatsoever over the next 1 to 3 years, as a bookend for the potential management decisions in between. At the other end of the scale, at the end of the scale of 50 to 60 million pounds of removals, you see at 60 million pounds, the trend is pretty strongly downward. Although we have a large amount of uncertainty in the forward projections, it's pretty clear that at 60 million pounds, we have a very high likelihood of stock decline over the next 3 years. Now, if we go into the details of the table, now again, the reference line right down the middle, the first block in the table represents stock trends. So what is the probability of stock decline over the next 1 to 3 years? And you can see here that we're getting between a 70 and 80% chance of stock decline over the next 1 to 3 years, even at the reference level. However, the probability of a stock decline of at least 5%, or a big stock decline, is less than a coin toss over even out to 3 years. It's only 46% in the 3rd year. So that indicates more or less a stable stock at the reference level over the next 3 years. If we move then down one more block in the table into the stock status, this is what is the probability that we'll drop below either our 30 or our 20% reference points. And you can see across the middle of the table, across this finer grid of alternatives here, there's a relatively low probability, no more than 1 in 5 anywhere in this part of the table, that we will dip below our 30% reference point. So there is still a buffer between where we are now and that reference point. However, moving down into the bottom of the table, which represents the probability of decline in fishery trend, or in TCEY, you see that there is better than a coin toss across much of this part of the table, or better than a 50% chance that we will see a decline in the fishery yield sometime in the next 3 years, even around the reference level of removals. And that's because we're seeing the year classes moving. Now, excuse me, into a more finer grid into the table. So now you'll see that there are options of F42, 44, 46, 48, and 50 in this table. So as management decisions and as different alternatives come up this week, hopefully this provides a slightly finer grid to evaluate management choices over a range around the reference level. And I've called out 2 of them here, F42 and F50, to show you graphically what those 2 different projections look like. And so this, I know this is going to be relatively unsatisfying to some of you, which is that over a range of almost 8 or a little more than 8 million pounds of removals, visually, there's actually not a huge difference in the trend of the spawning biomass over this time period. The probability of decline does go up substantially, but I think it's important to note here that overall, the spawning biomass is still relatively robust over that 3-year time period, even given the difference of over 8 million pounds of removals during this time period. Now, I generally take a short pause here, and I'm willing to do that at the discretion of the commissioners, but I think given the place that we are in the day, it might be most expedient for me to go ahead and finish my last 10 or 12 slides, but I will leave that to the discretion.
Take 2 swallows of water and then go on.
I'm sorry, it's quite hard to hear here.
Take a swallow of water and then go on.
Okay, thank you. I actually forgot my water bottle, so I'll just continue on anyway. We'll move now into the individual regulatory area specific projections. And I only have a few slides left here, so this last part of the talk will go relatively quickly. The most important thing to remember as you all are getting ready for the decision we've made at the direction of the Commission, this year the decisions are going to be couched in terms of TCEY. And that's an important change because there are some additional components included in the TCEY that are not included in the fishery CEYs. So note that as we go through this process, it's important to recognize that many of the numbers that are going to be thrown around over the next several days will be TCEYs that will not be directly comparable to the FCEYs you may have been thinking about in past processes. I will, however, direct towards some tables at the end of the catch table document. I believe that's document 11, which provides you a historical comparison of both FCEYs and TCEYs. So you can see over the last 5 years for TCEYs and even farther back for FCEYs, how those compare to the adopted catch limits. So we've tried to provide you a little bit more historical context there. Well, what does that actually mean for the calculations? Thankfully, it doesn't mean anything for the calculations. Thank you, Tom. Brought the whole bottle. I must be in trouble. What does this mean for the calculations? It doesn't mean anything for the calculations. The move from FCEY to TCEY merely makes the interpretation easier as we start to aggregate across different components of this table. The top 2 portions of this table are only there because we need to delineate between the parts that are included in the FCEY and the parts that are not. When we don't worry about that, we can focus just on the TCEY, and all the calculations are the same throughout. Now, what's important, I think, to remember is that as different alternatives are floating around this week, I will be able to create a full table for any alternatives so that any TCEY in any regulatory area can be translated into an FCEY right away at this meeting. So if you feel like you need more information to interpret a TCEY, make sure you contact one of the staff if there hasn't already been a table produced, and we'll produce you a full table so you can see how that translates not only into FCEY, but down into all the components. The idea is to make this shift from FCEY to TCEY as transparent as possible as we move forward. So now we get into how we actually do the catch table projections. And there are two components. The first is scale, and this is the overall level of removals set from the coastwide stock assessment. And by default, we use the reference SPR of 46%. However, I note that in the document, as well as during this week, we will produce other alternatives. So there are other scales that we can use to evaluate these catch tables. And you'll find at the back of the catch table document, you'll actually find tables representing those different SPR levels of 42, 44, 46, 48, and 50. So you can actually break down of each of those levels into individual regulatory areas. The second component is distribution, and we've not changed the method here. We're still estimating the stock distribution based on 032 survey biomass, and we're still applying the same relative harvest rates that we have used historically, which are higher on the eastern side of the stock and lower on the western side of the stock, with that dividing line between Area 3A and 3B. However, again here, we can compare other TCEY distributions as well. So if there is an additional alternative that needs to be evaluated during this week, we can provide tables that have other distributional assumptions in them. So to put this year's results in context, the 2017 reference level was a total of just over 39 million pounds, and the adopted TCEYs, noting that they were in fact adopted in FCEY, but were translated into TCEY, were almost 41 million pounds. The reference level for 2018 is an even 31 million pounds. And there are two changes here. One is in the scale, but the second is the distribution of those removals has also changed. And that distribution, again, is a function of the stock distribution and the relative harvest rate. So I'll give you one example of how much can change in a single year. So last year, we saw our stock distribution estimate for Area 2B was 14.1% of the coastwide stock. From this year, in 2017, that's decreased to 11.3%. That's a 25% change for that particular regulatory area in the percentage of the overall stock that we estimate in that area. Now, that's on the individual regulatory area level. At the regional level, these changes are much smaller. So we saw only a 5% change at the regional level, indicating that if we aggregate all of Region 2, there's been a much smaller change in stock distribution than we see if we drill into the individual components. But note that the stock distribution is going to change, even for the same overall catch level, will change the distribution of those among the regulatory areas. So this is the full table, and this is in the catch table document as well. This is updated to reflect the bycatch estimates that were provided to us in January. And this provides you with the full breakout across all the different sources of removals. Now, if you're interested in how this affects your catch sharing plan and how it compares with FCEYs, then this is the table for you. If you want to evaluate this in terms of just adding up the removals and trying to compare across regulatory areas, not trying to remember whose catch sharing plan from whose, by working in TCEY, which is in fact just this row across the middle of total 026, we can make a much more direct comparison across the different regulatory areas, see where the sources of removals are and how they break out across the components. So I'll show you these data now in a graphical way. Hopefully you can see quite quickly. Sorry, but before I do that, I want to make one last point here, which is that we've simplified this table, and there's one more simplification that could be made here, which is that at the coastwide level, we're looking at less than 50,000 pounds of discard mortality in the commercial fishery. So I would say this is an unimportant component to keep separate. It has historically been separated from the TCEY, but for ease in interpretation, it would not be a big deal to include that in with the TCEY, only maintaining the bycatch, the U26 bycatch, outside the calculation because it is a substantial component and it represents ages and sizes that are well below that 026 cutoff. So if we look at this graphically, this is the reference catch table now divided out across the regulatory areas and into components, noting that those first 5 colors represent the TCEY. And you can very quickly get a sense of where how the removals would be distributed across the coast under that reference catch table. Now, if I turn this now into percentages across each area, noting that the scale is quite different, this allows us to see the difference in the importance of each component across the regulatory areas. The reds and yellows indicate the recreational and subsistence removals, and you can quite quickly see that those are most important from 2A through 3A. can see the bluish and the greenish colors represent bycatch, and you can see those are important across several regulatory areas, but most important out in Area 4, C, D, and E, where they comprise the majority of the overall removals from the stock in that area. Now, that's the reference table, and that's provided for continuity from year to year, so we have a point of reference to compare to previous years. However, we can, as I pointed out, we can create additional tables for any alternatives that are needed during this week. And I'll provide a couple of these just to start off the discussion. The first of these is a table that's been requested in the past. There's a version of this table in the document, but not quite the same as this, which is one place where consideration could begin for this process is with full regulatory bycatch removed from all the regulatory areas. And this would essentially be an expectation that all possible bycatch that could be removed was in the upcoming year. And I provide this for your comparison, noting that two things. One is that we, in fact, run out of biomass in Area 4, C, D, and E. And in order to meet that SPR target, we need to redistribute some of those removals to other areas, or redistribute the reduction in those removals. And the second is that then we see that subsequently in reduced TCEYs across all the regulatory areas. In order to meet that same SPR target, we're now down to 29.4 million pounds of TCEY. Now that's one alternative catch table for consideration. A second alternative catch table for consideration would be, what would it look like if we took last year's catch limits again in 2018? Now, noting that if we roll those TCEYs over, some of the components inside the TCEYs have changed. So the FCEYs associated with this alternative will not be the same as the FCEYs we saw last year, even though the TCEYs match. So if you're interested in this table, you can compare this to the FCEYs from last year and see how things would change if we rolled over the catch limits in TCEY from the previous year. Now, importantly, if we did this, you might expect, well, you take the same amount of catch, we should get roughly similar result, except we've moved 1 year forward. So we have 1 more year of weaker recruitments coming into the stock. And in fact, what that means is that if we took those removals or those same catch limits from 2017 and rolled them over for another year, we would expect that that would actually correspond to an SPR of 38%, or a higher level of fishing intensity than we estimated for 2017, even with the same catch limits, because that reflects the reduction in the stock moving forward from 2017 to 2018. So again, we can create other alternative catch tables and diagnostics on those tables as needed during this week. I conclude this with the Secretariat's recommendations to the Commission regarding these documents. The first is to note these documents and the information contained in them, which hopefully is sufficient to provide for this week's decision-making process. The next is to request of the Secretariat any further analyses as the week goes on that may be required, particularly additional catch tables for evaluation by the Conference Board, the Processors Advisory Board, or the Commissioners as the week goes on. And the third would be if there are avenues to the presentation of these results that might be helpful in the future, to provide those for consideration by the Secretariat over the following year, so that hopefully we can continue to improve our performance here at the annual meeting at next year's meeting. And with that, I'll wrap up my talk.
Thank you very much, Dr. Stewart. I see that you spent exactly the amount of time you were scheduled. So well done. Let's see if there's questions or comments from the commissioners first. Commissioner Benken.
Thank you, Ian, for another excellent presentation, answering most of our questions before we even ask them. Want to clarify my understanding of some of the data sources. So when you give us numbers per unit effort, that's from the survey. And I think if I'm understanding correctly, that's 026 fish. Is that correct?
The numbers per unit effort in those graphs that I was showing, the numbers per unit effort are all the catch of fish that we see in the set line survey. So it's not limited to 026, it's all the fish. But we catch very few fish in the set line survey less than 26 inches. So those are pretty consistent. But it is if we happen to catch a fish less than 26 inches, it is included in those numbers per unit effort.
Okay, well, so if I could follow up. So then when you give us the tables of the recruits and expected recruitment strength going forward, and you have, and the axis there, age 0 recruit. Now, is that including information from the trawl surveys that is partially informing our estimates of the strength of those year classes where the fish are still really small, or is that strictly still coming from the survey?
It's a good question. So the trawl survey information is included in the overall analysis in the form of weighted age for young fish. It's our only source of information for weighted age. So I do use that information to deal with those smaller fish in terms of model dynamics. However, we do not include the indices of abundance or the numbers per age from the trawl surveys explicitly in the stock assessment model. And the reason for that is that we don't have a single source that's geographically comprehensive. And historically, we've seen a poor performance in using the year class strengths identified in the trawl survey, particularly the Bering Sea, as indicative of year class strengths coming into the stock assessment. So the estimates of recruitment that you see in my results from the stock assessment are informed only by the fish that we see in the setline survey. And that's why I don't extend those graphs beyond roughly the 2013 year class, because that's about as far back as we can see with the setline survey. I do have, if you're interested in seeing them, I do have, and they're in the data overview document, some graphical information that summarizes both the trends as well as the age composition data available from the trawl surveys in the Gulf of Alaska and the Bering Sea, as well as the age composition data from the aggregate bycatch information, which also encounters those young fish. So if you look in the data overview document, you can find figures of all that information for comparison, noting that you should definitely use the year class strengths that you might be tempted to infer from those graphs with caution, because they have not historically provided a good indicator of year class strengths as we subsequently see them in the halibut stock.
Thank you. Other questions, commissioners? Do you have another one? Commissioner Bacon.
I do, thank you. One more question. So last year when we thought we were setting the TCUI, it's a horrible echo, at 46, we came back this year and it looks like from your estimate now, we were closer to 38, right? Fishing intensity on the stock. So is that level of decline that we saw in the stock between last year and this year, I can't remember what the estimated risk probability of seeing that, it's roughly 20% decline, was last year, but was that what were you projecting that kind of a decline with that kind of risk?
So I'll go back to this figure, and you're making 2 points here, and I'll try to address both of them. The first is that it appears that the scale of our estimates has changed slightly from last year. And that is in fact true. So the reference level of F46%, which you see here as a purple line, was actually lined up through the 2013, 14, and 15 points last year. It was actually the average of those 3 points. So what this means is that now looking back, we're estimating in the last few years, fishing intensity was actually a little bit higher than we thought it was. And that's because the drop in numbers this year affects not only the terminal estimate, but it's also informing those year classes that were only partially informed during last year's process. Now, in terms of the projection, I'll note that last year's adopted catch limits were not equal to the reference level. They were in fact projected to have an SPR of 45%, not 46. And so already that was a higher level of fishing intensity than the reference level. And that did correspond to a greater than 50% chance of stock decline in the upcoming year. Now, it's difficult to say, was this exactly consistent? Well, there was a high probability that we would see this level of decrease. So the declines we saw from last year to this year are well inside the confidence intervals that were provided from last year's stock assessment. So unfortunately, I think this year's result is consistent with where we've been. I will note that I think one of the places where we perhaps didn't get as much information as would have been helpful last year is that until last year, we were very caught up on this concept of eBio. And eBio really only included fish that were largely mature fish and older fish. And unlike the figure that I showed you with 8+ biomass, where you could actually see this decline coming for a couple of years, by focusing on eBio for a number of years, I think we failed to get as strong an indication that this was coming. The recruitment estimates that I had in last year's stock assessment were actually very consistent with what we're seeing this year. They were still low over this period from 2006 onward. But I think in terms of showing you trends of how that was going to feed in, the move this year away from eBio, I think, has helped us see this a little bit more clearly than perhaps we did during last year's process. So that's an important and, I think, informative step forward.
Yes, thank you, Commissioner Ryall.
It's a little hard to hear. There's an echo, and so I just wanted to make sure I heard what you said correctly, Ian. But before doing that, I thought your efforts to try to explain the changes in recruits was very helpful. The number of graphs you added, the 3D one, it was quite multicolored, but I did find both that and the other ones showing the individual projections really helpful to explain changes, what you think are happening with recruits. In 2017, we adopted a TCEY of 40.75, which resulted in a projected SPR of 45. And then we actually realized a harvested TCEY of 42.5, which resulted in an SPR of 40. Is that correct? And so then the reason for that decrease from 45 to 40 in SPR was partially that we harvested more fish, but was it also because that your estimate of the actual amount of biomass or the total population is less too, or is it?
That's correct.
Thank you.
More questions, more comments? Well, I agree with Commissioner Ryall. I thought that you did a great job of changing some of the presentations just slightly from the interim meeting that made it very clear. So well done. This is our time for the public comments. And so let's see, do you have the list from back there up here? So apparently no one has signed up. So perhaps since it did get kind of late, maybe we can open tomorrow morning's session with a public comment, and we'll try not to spend a long time on it, but at least people will be able to think of their questions. We'll pick that up. We do have national delegation meetings tonight, starting at 6 o'clock. So it's already 5:30. So we have just half an hour. The U.S. delegation is meeting in this room again in half an hour, and the Canadian delegation is next door that way. And so with that, and no one is online with a comment right now.
I did have one question online, if you like.
Let's do the one online in the event that online person isn't on in the morning.
Right, thank you, Mr. Chair. This is two questions together from Kevin Abena, who asks, and this came in earlier during your discussion of the data, Dr. Stewart, is the summary for Area 4D that fish are moving to St. Matthew area, or could it be instead a larger fishing effort around St. Matthew Island?
I'm sorry, what was the second part of that?
Or could it be simply a larger fishing effort around St. Matthew?
I think that the results that we saw in the setline survey are indicative of a true increase in density and likely abundance of fish around St. Matthew Island. I'll note that the area in the Bering Sea is somewhat unique in that you have a very large geographic area with very low density and a few locations that tend to aggregate fish from that density. And as many of you know who fish in those areas, those aggregations are not stable over time. They occur at certain times of the year and in certain places. And I think that this year, for whatever reason, both the survey and the fisheries found that increase in density around St. Matthew Island, and we see the results in both time series.
Comment?
Thank you very much. So thank you, Dr. Stewart. And again, I'm sorry to impact your schedule, but we are contemplating some public comments, perhaps at 9 o'clock in the morning. So if you can do that, that'd be great. And let's see, we might have just a couple of announcements. Ms. Parker, would you like to make an announcement?
Grab the mic.
Up front.
Right up here.
Thank you. Is the mic on? Oh, hello. Oh, that works. Thank you very much. Two things. I just wanted to let you know that I tried to sign up, but it was either not taking the keystroke or what, but still, can everyone hear me now? I just wanted to invite everyone to tomorrow night's industry reception that follows, sorry, Wednesday night. Thanks, Steve. I'm blaming my cold on everything. This is an industry reception that we always have here, and it's to honor the staff at the Secretariat. It starts at 6:30, goes to 8:30, and it will be at the Crystal Ballroom in the Benson Hotel. And everyone is invited, and I hope you all come. Thanks.
Thank you very much. And with that, we will adjourn for the evening and start at 9 o'clock in the morning. And again, we have the delegation meetings tonight, both of them starting at 6.